So hello. Hi. Hello everybody. Hi, how are you, Eleanor? Right. Okay. So everything's good. Eleanor, మీరు అందరికీ చెప్పండి ఒకసారి. So I'm really sorry for, conducting this lecture late, Kani. I hope we'll cover the entire chapter of your fluid dynamics in a single shot. Chusko. So lecture start చేసే ముందు I want to introduce you something about your offline scholarship program by Vedantu. And it is the 77th Republic Day. And corresponding to that, there is a 77% discount scholarship in all offline centers. Okay, in the offline centers near you. Yes. I'm fine. Hey, not 34 minutes later. Okay, so please have a visit and have your books, have your slots booked. Okay? In session lo, we'll be talking about your fluid mechanics. Andariki. I am not 34 minutes late. Okay, I am only 4 minutes late. Not even 4. Okay, I am 2 minutes late because the class was scheduled at 8:30. Hi. Hello. So, how is the energy? The lecture might extend until 12:30, 1 or 1:30. I don't know. Mac will tell you. Give me 1 minute. Hi. Hello. Hello, Andariki. Right. So, this particular chapter, and fluid mechanics, it is the last chapter from your mechanics branch. Once this chapter has been completed, my entire mechanics has been completed. Chuskondi. So your mechanics and your electrodynamics, they have completed. At the same time, your waves also. Chuskondi. Okay. So 3 branches, they have been completed in physics. It is my promise to all of you, ide na promise, that I will help you score 140 plus. The only thing is sincere dedication from all of you. They are understanding? Yes. Once this syllabus has been completed, we are directly jumping to your PYQs. Our PYQs lo kuda we will be taking full time marathons. You are understanding? Yes. Sorry. Good. So give me 5 minutes. Duration will be somewhere around 4 hours. 4 to 4.5 hours. And then we have to cover it. If possible, we will try to wind up early. It will take somewhere around 4 hours. Okay? My target will be to cover, yes, rabbit 150, 160, 170, 180, up to you. Okay, up to you. 140. And lifting you up to this height is my responsibility. Then jumping or not jumping, it's up to you. Okay? Sir, give me 5 minutes. 5 minutes to start with them. Why not 150 enter? Sir, good, good. Where's the pen? Hey, where is the pencil? Student, so let us start the session. Right. Kanmani, it was not in my hands, okay? I tried to start earlier, Kani. There were some problems from my end, not my end, from the technical end, okay? So the problems did not let me start your class earlier. Sorry, start with the Mandani. So, fluid mechanics law will be majorly talking about your liquids. Okay, liquids. Yes. Very good. All of you, very good. Student. So, till now, we have talked something about your solids. Chuskondi. Properties of solids. Completed kada? Yes. We have talked about your stress, strain, coefficient of elasticity, about your bulk modulus, Young's modulus, and all these things. Okay? Right. We will talk about your liquids. Liquids ante we will talk about your liquids in your fluid mechanics chapter. And the only state that is left is gas. Gas kada? Gas kosam ma daggara 3 chapters unnayira. The first one is your kinetic theory of gases, thermodynamics, and thermal properties of matter. Ide you understand? Right. So, in this session, we are talking about your fluids. Fluids ante your liquids. Okay? And you know the basic terminologies. I'm not going to express what are solids, what are liquids, intermolecular forces, and all these things you know. Okay, my major focus is to directly let you shift to your core concept. Core concept ante entira. We are simply starting our discussion from pressure inside a liquid. What I'm telling? Pressure inside the liquid. Okay? Right. Listen to me, all of you. Listen to me very carefully, okay? Yeah. We can classify your entire fluid mechanics into 2 types. There are 2 categories. One is your fluid statics and the second is your fluid dynamics. Fluid statics law, your fluid will be at rest. You do whatever you want to do, Kani, your fluid will be at rest. You're understanding? What about fluid dynamics, sir? Fluid dynamics law will be just looking at the parameters when the fluid is moving. Only 2 things, okay? KTG will start once this chapter has been completed. Maybe tomorrow, your modern physics tarvata. Okay? Mostly after your modern physics only. That will be the last branch I will be discussing in physics. Then we will just directly jump to your PYQs, okay? Student. So pressure gurinchi maatladtam. Before that, even before the pressure, you need to know some basic terminologies. What is volume, sir? What is density and what is mass? Ide keda? Student. Hey, all of you. Let us start from the basic discussion. Your density, what is your density andariki? What is the density? What is density? Can you define density? Can everybody of you define density? Hey, Babu, chappura. Density is nothing but it simply tells about the mass confined in a given volume. In a given volume. You are understanding? Good. And your density is equals to total mass upon total volume. Try to understand, all of you, okay? We will go step by step. I want everybody of you to take a pen and paper. Right, correct. So, let us talk about some questions, okay? I'm giving you one question. Andariki. Hey sir, simple topic sir, density. And the question is no sir, because there are some twists that you might not understand. Hey, who is it? Who is it? Let us take a question. A sphere of mass 1000 kgs, 100 kg, and radius change. I want the final answer. Don't tell me the steps. ఒకటే ఆన్సర్ చెప్పండి, yes or no. It will swim or it will sink రా. అదే చాలా basic question sir. It must be understood by each and every one of you. What does it mean? If you're not understanding, that means your 8, 9, 10th class basics are not good. Okay. Okay, చూద్దాం. Hey, listen to me, okay? It's a very basic question. All of you. చూడండి. Let us talk about density of sphere కదా? Yes. And let us compare with the density of water రా. అంటే if this is your water, ఈ water లో you are putting a sphere కదా? Yes. So if you are putting a sphere into this water, the question is, it will sink when? Sir, if density of sphere is greater than density of water, ante sinking. Leda density of sphere is less than density of water, ante floating. Ide kada? So let us calculate the density. Kani, to solve the question, you need the density of water. What is density of water? What is the density of water? చెప్పండి ఒక్కసారి. What is density of water, sir? Sir, density of water is equals to 1 gram per centimeter cube లేదా 1000 kg per meter cube. ఇది గుర్తుండాలిరా అందరికి. It's a very basic property. Your NEET aspirant does not know density of water అంటే you sink into the water. Okay? Not wine. Okay, very good, very good, very good, very good. Let us calculate the density of the sphere now. Cheppandi, density is mass upon volume kada. Volume formula entira 4 by 3 into pi value 22 by 7 into r cube. R cube is 2.1 whole cube kada. Yes, so it is nothing but 21 whole cube into 10 to the power minus 3. Idigo. I'm directly writing in terms of numbers. Okay, directly writing in terms of numbers. Mass ante 100 kgs ra. Ade. So this 7 3s are 21. 121 is gone ra. You can simply say, sir, volume of sphere is equals to 4 into 22, sir. 100 divided by 4 into 22 is how much, ra? 88. Multiplied by, cheppandi. 88 into 21, kada? 21 into whole square is 441, ra. Multiplied by 10 to the power minus 3, ra. It will go in the numerator, becomes plus 3 and 10 to the power 5. And 1, 2, hey, 5 kada? Yes. 1, 2, 3, 4, 5. So it is 1 lakh. Divided by, cheppandi, what is it, ra? 441 multiplied by 88. What is the value of 441 times 88, ra? Approximate value తీసుకోండి, approximate. Sir, 400 into 80. 36,000. 36,000 kada? Yes. So even if you are saying it is roughly around 50,000, ra, roughly around 50 to 60,000 divided by 1 lakh, చూడండి. 1 lakh ante enti ra? That means this is simply approximately equals to 2. Hey, లేదా 3, లేదా 1, whatever it is. Kani, the density of water is 1000. Hey, 1000 ra. Here 1, 2, 3. Here 1000. And density of water is too high. It will not sink. It will float. Okay. It will float. Not sink ra. It will float. Your understanding, okkasari mee daggara mass volume unte, you must be able to tell will it float or it will sink. It's a very basic simple question. Yeah? Hey, let it be ra. Chudandi. Now we have 3 conditions. Ante density of object, density of water. Ikkada kuda you have density of object, density of water. Here also you have density of object, you have density of water. Chuskondi, all of you. The question lo, if you are a very sincere NEET aspirant unde, you should ask me a question, sir. You should ask me a question. Okay? In this question, you should ask me one more question if you are a sincere aspirant. Leave it. I'm also not going to tell you. Okay? This question is actually incomplete, I would say, from a broader point of view. Okay? Kani, if you look at it, it is complete. I'm not saying it's wrong. It's right. Kani, there should be one more question that you should ask. But you're not asking. I'm also not interested. Leave it. Hey, Hemendra, what's happening? Okay, sorry. So, when I'm saying objects, my dear students, when I'm saying object, let us say your object is cube. You're understanding? Cube, leda, sphere, leda, whatever you want to do. So, if you have water, all of you, try to understand. Object into your cube, okay? Your object is your cube. First condition lo, all of you try to listen. First condition lo, your density of object is more. Me second case lo, density is less, and in the third case bhutari. Can you tell me how will the scenario ra? Can you tell me the scenario? Ra? And this is your cube, all of you. Here, in case lo, density of cube is more than density of water. Ante enti ra? Ante it will sink. This is your cube, sir. This is your cube. Gone. What about this case, ra? Your density of object is less. density of water is more and it will float kada? Yes. So this is your object. E case lo, can you tell me what will be the scenario? Can you tell me the scenario in this case, all of you? What will be, hey, it will sink or it will float, ra? Float only. Float only. Hey, it will float, it will float, it will float. It will sink. No, sir, it will not do anything. It will float or it will sink. All of you. Can anyone of you tell me, ra? Partially float. Okay. Partially float ante enti, ra? What do you mean by partially float? It's a very basic question, kada. It's a class 9th question, all of you. If the densities are equal, what will happen? It will not sink. It will be like this. Children, ante the upper face just touches the surface of the liquid. Understood? If the densities are equal, the upper part of the cube, it will be exactly touching the surface of the water. Idigo. Yes, Bhanu, solids over. Completed, already completed. Okay, sorry. So with that all being done, hey, you are done with your density, you are done with your volumes, okay? You are done with your right. Everybody. Now let us talk about pressure inside a liquid. Okay, pressure inside a liquid. Andariki. I will explain you in some bullet points. Okay. Point number one. Whenever you are talking about the pressure, direction మాత్రమే గుర్తుపెట్టుకోండి, because the direction has a lot to do with your chapter. Okay? మొదటిగా you will be listening లేదా focusing on the direction. Sir, pressure is a vector quantity, sir. Is it a vector quantity, sir? No. మరి ఎందుకు చెప్తున్నావు సార్ డైరెక్షన్ గురించి? If it's not a vector quantity, what do you mean by direction of pressure? I will tell. దాని తర్వాత let us talk about the variation of the pressure in a liquid. Okay, variation of pressure in a liquid ra. అదే pressure is equals to force upon area kada. Try to understand. Okay, try to understand all of it. Pressure is equals to force upon your area. అదే కదా? Yes. So if at all I have a container ra, అందరికి చూసుకోండి. If at all I have a container, in this container I am filling some liquid అంటే వాటర్ తీసుకోండి రా, వాటర్, నార్మల్ వాటర్ తీసుకోండి. ఇప్పుడు if I see any point of the water అంటే ఏంటి రా? ఎనీ మాలిక్యూల్ తీసుకోండి. మాలిక్యూల్ అంటే తెలుసా? H2O మాలిక్యూల్ రా. ఓకే, let us say there are n number of molecules into this container. దాని నుంచి I'm taking a single water molecule. చూసుకోండి, this is a water molecule కదా. ఇప్పుడు I can simply say that the pressure exerted by the entire fluid, on this particle is symmetric. Hey, symmetric ante telusa? Symmetric ante the pressure will be exerted from all the directions ra. Idigo this, you are understanding? It will be in each and every direction ra. Try to understand. I hope it is understandable. Okay, what about the walls, sir? Walls gurinchi cheppandi ra. The pressure on the walls is like this. Chuskondi, these are the basic terminologies. Okay, all of you understand. These are the direction in which the pressure is exerted on the walls. You insert whatever you want to insert. Andariki, try to understand. Okay, I am only talking about the direction of the pressure. I am not coming on the values. Okay, so ide container lo, if at all you are dipping a cube. Chuskondi, cube. So if at all this is your cube, all of you, try to understand. Okay, ide me cube unte, what you can say ra? What you can say? Cheppandi. Can you tell me the pressure ra? Can you tell me the pressure? Sir, if this is your cube, this face will be experiencing pressure like this. Upper face gurinchi cheppandi andariki. Upper face will have pressure like this. What about this face ra? This face will have the pressure something like this. Ide kada? What about this face ra? This face will have something like this. And lastly ra, hey, chusko, how many faces are there? You can visualize by yourself kada? Yes. And lastly, this phase will be experiencing the pressure, something like this. Try to understand. Each and every phase experiences pressure perpendicular to the surface. You are understanding? Yes. Direction ante it is symmetric ra. Ade ante kada? Yes. Your pressure is symmetric in a liquid. Dan tarvata it is perpendicular ra. Perpendicular. The pressure is perpendicular to every plane లేదా every phase. You remember this condition. It is very, very, very important, all of you. Try to understand. Okay? Sorry. What will happen? Hey, cheppandi. I want the answer from all of you. Okay? This is my container. Okay? This is my container. All of you. This is my container. The question is, in container low, if I am putting a sphere. Cheppandi. If at all I am putting a sphere into it. This is your sphere. Andariki. Can you tell me how the pressure will act? Pressure direction cheppandi ra. Is sphere. The pressure exerted on the surface of this balloon ante sphere. Whatever you want to consider, you can consider it. Okay? It's a balloon ra. Can you tell me the pressure directions? The pressure will be exerted from each and every direction. You are able to understand? And equal pressure from each and every single direction. Yes. Try to understand, all of you. So if this is your balloon, the water pressure will be exerted from each and every point. You are understanding? So this will be your pressure. And due to the external pressure of water, due to the external pressure of the water, ee balloon lo you have air kada? Yes. The air gets compressed. Compressed ante the size of the balloon shrinks. Chuskondi. So in e case lo the size of the balloon will shrink down. Ide kada? It has been compressed from all the directions. Ante it will retain the shape. Spheres unte it will remain the sphere only. It will not change ra. Okay, it will remain the sphere only. Sir. Anyways. Okay, so let us talk about the values. Okay, values of sphere. Chuskondi. Ee value kosame we will try to do some assumptions. Andari. So if this is your container, hey, try to understand. Okay, ee container lo you have liquid kada? Yes. What about outside the container, sir? Yes, size of the balloon is decreasing and it will remain spherical only. It is experiencing pressure from all the points in symmetric directions. Okay. Yes. If it is taken out, it will retrieve its shape. Okay. If it's taken out, it will retrieve its shape. You don't have the problems, Kani, for our time, okay? There was a condition, ideal gas equation, PV equals to nRT. So gaseous state was a chapter in your physical chemistry. It's not there for you. Chapter lo we discussed a number of questions, okay? A sphere is dipped into the water, into that height. Find the change in volume and all these things, okay? Choose one. Let us imagine, all of you, try to understand, okay? Let us take an imaginary cylinder. Ante entira? You imagine there is a cylinder into this water. Okay, cylinder. Imagine, only imagination, not real. Only imaginary cylinder తీసుకోండి. If this is your imaginary cylinder, andariki, it is made up of water only, okay? It is made up of water only. Try to understand. Okay, right, perfect. ఇదే కదా? Try to understand. What about the external pressure, sir? External pressure is atmospheric pressure. 1 atm. 1 atm kada? Yes. 1 atm is the atmospheric pressure. External pressure. Ante the pressure that this phase experiences is P naught ra. Idigo area A naught A anukundi. Okay. Here also you can say area is A. What about the force exerted by the downward part? Choose all of you. Try to understand. Okay. Try to understand. Whenever we say you have a liquid, static liquid and telusa, static liquid in the sense each and every molecule of that liquid remains in the same position. Until there is no motion of liquid molecules. Jagrataga vinandi, all of you. If I say this is a molecule of liquid, this molecule ra, that means it is exactly at this space. It is not moving up, not moving down, not moving left, not moving right. You are understanding? Try to understand. Static liquid ante ide. Each and every molecule of that liquid should be on its own place. Ante this liquid ra, can you tell me who is supporting it? It is in the air kada. Air ante it is in the liquid ra, liquid only. Chuskondi. When it comes to these levels, chusko. When it comes to these liquid molecules, we can understand, sir, the container is supporting them. Ide kada? But what about this ra? Who is supporting it? Who is supporting it? And you will simply say, in case low, there is mg force of this liquid molecule that is acting downwards. Ide kada? Yes. Mg acting downwards ra. Kani paina ki? It is in equilibrium kada. It's not moving. And it's a balanced scenario. In balanced scenario low, its mg should be balanced by some other force. Ide kada? Yes. Let us assume that force is F. Ide kada? Yes. Let us say that force is F. Andariki. Ante, if you talk about liquid molecules, there is a force acting in the upward direction also. Okay. There is a force acting in the upward direction also. This force ni F anukondi. Let us say that force is F ra. Let us say that force is F. You are understanding? Leda, rather than force, let us just discuss, sir. There is this pressure P. Due to this pressure, this cylinder, it's imaginary cylinder kada, and it is made up of water molecules ra. And ippude cheppina, if the liquid is static liquid unte, each and every molecule inside this cylinder must remain at its own position, right? They are not moving at all. Ante ee mottam cylinder ni choose, you can say that this is at rest. You are understanding? So if it is at rest, ante ee cylinder pai net force becomes zero. Ide kada? Net force zero undali ra. Your net force on the cylinder must be zero. Ante it's an imaginary cylinder. Malli okasari cheptunnanu. You don't say, sir, where are the walls of cylinder and all these things. It's an imaginary cylinder. Okay? You make it an imaginary cylinder out of the water only. Ra. Hi. Good evening. Right. Hi, hello. Now, net force is equals to zero. Kada. Can you tell me what is the net force? Ra? Can you tell me what is the net force? Andariki. Can you tell me what is the net force? Ippudu, let us say the density of the liquid is rho. Point number 1. Ide kada? Yes. Let us say the height of this cylinder is h. Try to understand the terminologies. Ippudu, can you tell me the net force is acting ra? The first force is due to the atmospheric pressure. Chuskondi. Pressure kada? Yes. What about the second force? Second force, it's its own weight mg. Weight of the cylinder. Downwards kada? Yes. And what about third force? This pressure that is acting upwards. Finished. Sir, the net upward force must be equals to the total net downward force. You are understanding? Ippudu chudandi, area A unte, pressure is P naught, area is A. What is the formula, sir? Pressure is equals to force upon area. Ide kada? So ikkada nunchi your force comes out as pressure into area. Ante meeku ee phase pai force kavalante, you multiply this pressure with area ra. Cheppu. What is the force on the top of the cylinder, sir? P naught into A. Ide kada? What is the force at the bottom face of the cylinder, sir? Sir, P into A. Ide kada? Yes. So the force is P into A. Idigo. Raskondi ra. Andariki. What you can say, sir? Total upward force must be equals to total downward force. Kani, downward forces unnai ra. In the downward direction, choose P naught A and mg kada? Yes. So, sir, P naught A plus m into g should be equals to PA. Now, I want the value of mass. Sir, mass is density into volume. Density mass by volume kada? Density is mass by volume. One time mass is density into volume. That means P naught A plus mass is density into volume. Cheppandi okasari. Can I say area into height? Can I say area into height? Yes. Sir, area into height into G should be equals to P into A. Idigo A gone. That means P is equals to P naught plus rho G H. That means the pressure at any depth height kada? H is the depth. So pressure at any depth H is given as P naught plus rho G H. This is the standard formula for variation of pressure with respect to depth in a liquid. Andariki ardhamaindi, right? Now my question is something like this, try to understand. Okay, question is compare the pressure at points A, B, C and D. Okay, try to understand everybody. This is a liquid ante this is a pool ra, swimming pool ide kada. Yes, so there is this first tube. Okay, this is my second tube. Okay, this is my third tube ide kada. Yes, and 4 points unnadi kada, so I would need a fourth point, sir. Ee fourth point lo what I'm saying is ఈ ఫోర్త్ పాయింట్లో హౌ షుడ్ ఐ టేక్ రా, రైట్? This is a shape, okay? ఈ కంటైనర్ లో ఐఎమ్ ఫిల్లింగ్ ద లిక్విడ్. వేర్ ఇస్ ద కలర్ ఆఫ్ ద లిక్విడ్, సార్? వాట్ కలర్ ఆఫ్ వాటర్ రా, ఇదే కదా? ఎస్, చూసుకోండి. యువర్ వాటర్ ఈజ్ at right. Yeah, understanding. This is a liquid that is filled ra. ఇప్పుడు I want the pressure at 4 points కదా. ఇదిగో, this is your point A. ఇదే, this is your point B. Okay, let us take in the same line ra. Okay, let us say here is point A, here is point B. This is your point C and this is your point D. Try to understand. చెప్పండి. What is the pressure? Option A. Okay, option A. I'm giving you with the options only. Option A andariki. You can say pressure at A greater than pressure at B is less than pressure at C. Pressure at C is less than pressure at D. How are you doing, sir? Let us say pressure at A greater than pressure at B greater than pressure at C greater than pressure at D. Option C ra. PA less than PB less than PC less than PD. లేదా లాస్ట్ ఆప్షన్ PA equals PB equals PC equals PD. Why same at all points? Kiran Kumar Erraguntla. Why same at all points? చెప్పండి. గుడ్ వెరీ గుడ్ అందరికి వెరీ గుడ్. అంటే యువర్ సింపుల్ హింట్ ఈస్, చూసుకోండి, ఇదిగో ఇట్స్ అ వెరీ ఇంపార్టెంట్ అండ్ క్రూషియల్ స్టేట్మెంట్. ఓకే, అట్ సేమ్ హారిజంటల్ లెవెల్, ఇదే కదా? ఎస్, అట్ అ same horizontal level pressure is same. Try to understand. It's a very important statement. Ante same horizontal level kada, ante all pressures are same ra. Option D. Nice. Ippudu let us talk something about your terminologies andariki. let's go to the next topic only. Okay, question: force exerted by a liquid, okay, by a liquid on the walls of container. చూసుకోండి all of you. If the height is h, okay, if the height of the liquid is h ra, it's a cube kada, cube unte every wall has the area. Let us say the area is a. ఇప్పుడు నాకు ఫోర్స్ కావాలి కదా, yes, so you want the force exerted by the liquid, total force by, force exerted on the wall by the liquid. Do you know the formula? It's a direct formula andariki. It's a very direct and it's a clear cut formula. చూసుకోండి. I'm not going into the proof and all, okay? Directly formula చెప్తున్నాను, ఈ ఫార్ములా గుర్తుపెట్టుకోండి అదే. You don't require the proof ఎందుకంటే it needs some integration రా. We can do it. Take some elementary strip of length dx రా, అదే కదా, yes. And if the width, లేదా you need the proper measurements in this case, you need the, hey, what do you say, depth, okay, depth d unte your small length is dx, ide kada, so this is a strip width ra ade. And if you are taking at some distance x below, forget it. Remember this formula andariki, okay? Force on wall is equals to pressure average multiplied by area. ఇదిగో pressure average ante enti ra, pressure average ante you simply take the pressure at the top and bottom point and divide by 2, ide kada, yes. So that means sir rho gh, finished. Okay, toxic boy. So this is force on the wall, ide kada. With that being said ra, andariki, all of you, I want to give you a very beautiful question. Let us see how many of you can solve it. This is a container. Idigo, there is a liquid into this container. Andariki, density of the liquid is rho. Ide kada, yes. Ippudu what I'm doing is I'm throwing a cube. I'm throwing a cube into this liquid ra. చూసుకోండి, క్యూబ్ అంటే let us say the edge of this cube is A. This is A, ఇది కూడా A, and each and every edge is A. You are understanding? Right. If the total height of the water is 3A, అందరికి చూడండి, and this is A, this is A, and the remaining kuda A kada. Very understandable question, ra. Very understandable question. The question is find forces on each face of the cube. 6 faces, ra. Yes. 6 faces unte you have 6 different forces. Ide kada? How will I tell, sir? How will I tell? Do I have a cube, ra? I don't have a cube. Problem is that I don't have a cube actually. Okay. Yes. Top, bottom, side forces. What are the values? Values kavalira. Not sufficient if you're just telling the answers. I also want the values. Values gurinchi cheppandi okkasari. Hi. You're not getting them. Hello. Hey, all of you, try to understand, okay? Try to understand, everybody. I'm shading a color. Chusko. This, okay, this. You will understand. And you only take out the horizontal faces, ra. Horizontal faces and take this, sir. The upper and the lower face. Here go. Finished. Okay. If the upper and lower face is gone, and what face you are left with, ra? If the upper and lower face is gone, can I say that you have only this face? Side face, ra. Side face. Choose one. This is side face kada. Vertical faces. Leda you call them vertical. Try to understand. This is also vertical face, ra. Okay. And the below face, below, that's hiding. That face is also vertical face. So there are four vertical faces and 2 horizontal faces. Choose one. First vertical face, second, third, fourth. Ide kada? First, second, third, fourth. 4 vertical faces, all of you. Hey, 1, 2, 3, 4. 1, 2, 3, 4. If the faces are vertical, what formula you would use? Idera. Hey, this is a formula. This is a formula. This is a formula kada? Yes. Yes. Ante if your side is A andariki. Me side A unte what will you say the average force ra? Cheppandi. Force on vertical faces is equals to rho G. Cheppandi. What is the average height ra? Leda you can simply say total A kada. So take the half. A by 2. A by 2 multiplied by area is A square. So your forces on a vertical face is rho G A cube divided by 2. So there are these 4 forces. Choose quantity. One acting like this, one acting like this, one acting like this, and one coming from the behind direction. Something like this. Try to understand. Okay? And one acting like this. I don't know how to show you. Can you visualize cheskondi okasari? Okay? You can visualize it. What about the horizontal faces, sir? Upper face, lower face. Cheppandi. What about horizontal faces? Sir, your horizontal faces have a single formula. What formula? Pressure into area. Pressure into area kada? Yes. Yes. So if this is your vertical top face ra, if this is your top face andariki. Ide kada? Yes. You are drawing ra. But I am drawing it. Okay, this is your top face ra, and this is your bottom face. Andariki chudandi. Ide kada? So if this is your top face, this is your bottom face ra. Can you tell me the direction of force? Andariki. The force will be perpendicular to the surface from the top part. What about the bottom part? Cheppandi okasari. It will be something like this. Choose. Ide kada? What about this, sir? What about this force, sir? Sir, force is nothing but pressure into area. Ippudu pressure gurinchi cheppandi. Can I simply say ee mottam height 3A unte this height is A, this height is A ra, 2A already ochindi. What about the remaining height, sir? Remaining height is also A. Ade kada? Yes. Pressure at a height h leda pressure at depth D is given as rho GD, rho GH. Hey, rho GH. Hey, if it is P naught, it becomes, sir, the pressure on this face becomes P naught plus rho GH ra. What about this face? Can you tell me? E phase low ante your bottom phase low. Can you tell me the pressure, sir? P naught plus 2 rho GA. 2 rho GA. Look, sir, because rho G, what is the total value of depth, sir? 2A. Ante rho G into H. Can H value 2A unte? It should be 2 rho GA acting in the upward direction. What about the top part, sir? Top part is pressure into area ante rho GA multiplied by AQ. And here, I think I'm doing some mistake. Total pressure raskundira plus P naught kada. Ikkada kuda the same thing. Total pressure into A square. Hey, it should not be A cube, right? It should be A square. Keep correcting me, okay? This is the force on the top face and force on the bottom face. These are the 6 forces that you have calculated. Ante kada? Yes. Sorry. Try to understand. Ippudu, let us talk something about your buoyancy. Okay, andariki. Let us talk something about your force of spelling correct. చూసుకోండి ఒక్కసారి. If I'm doing mistake in spelling, right? It's not an English class. Okay. Sir, force of buoyancy ante enti, sir? If at all you have a liquid. Ante kada? The same thing, the same thing. What force of buoyancy, sir? This force, this force. Idigo. This force that is acting upward. Force of buoyancy. Understanding? Ledante you understand it in some different way. చూసుకోండి. If at all you have the liquid, all of you try to understand. Okay? Try to understand. what will happen is if you put a object, ఏదైనా object తీసుకోవచ్చు, you put it, where is it going, ra? It started misbehaving. చూసుకోండి. If this is your object, అందరికి try to understand what I want to tell you. Whenever you dip the object into the water, okay, ఇది చాలా సీరియస్ గా తీసుకోండి రా. Okay, this is your object రా. Initially it was here. What you are doing, you are slowly dipping it into the water, అదే కదా, you are slowly dipping it into the water. Try to understand. You are slowly dipping it. Why is it misbehaving? Yes, you are slowly dipping it into the water. మరి ఏమైతుంది sir? What will happen, sir? Slowly the water level increases, అదే కదా, water level increases. Archimedes principle అందరికి చూసుకోండి. What is it, sir? It is Archimedes principle. ఇదే కదా? Yes. So what will you say, ra? Can you tell me? So there is this famous story, ra. Okasari there was a king, he wanted to know about the impurities in the gold crown. You must have heard the story, okay? So what he did, he called Archimedes and he said that, hey, listen to me, ra. This crown has some impurities. Okay, find it, I will give you some price. So he was thinking, methods. Okay, he was bathing in the tub. So what happened is he placed his leg into the water, and a tub of water. And as he was sitting into it, the water started falling out. The water started falling out. So he was not wearing any clothes. So without any clothes, he started running. His mind got clicked. He got the way to find the impurities of the gold. So eureka, he started shouting, went out. Okay, that's a story. Now tell you if it's a true story or it's just made up. Can you choose one? But the principle is true for sure. Okay, principle is true. We are science students. Okay, we don't disrespect scientists. Understand? Hey, eureka, sir. He ran out naked, sir. Don't say that. He was a scientist. Respect him. Andariki. Respect. Yes. Now we will understand about your Archimedes principle. Okay? So it simply says that, if you dip any object, if you are dipping into the water, the volume of the water displaced is equals to the volume of the submerged object. It's a very hairline difference. Try to understand, okay? If an object is dipped into the water, if an object is dipped into water, the biggest twist of the plot. Yes, chigiri. The volume, it's not mass, okay? The volume of displaced water, right? Displaced is kada? Yes. Volume of displaced water should be equal to volume of object submerged. Understanding? If you want, I can take some questions on this also, ra. Okay. It's a simple principle, but the questions can be extraordinary, ra. But I don't want to go to that much of depth. Okay, volume guరించి మీకు అందరికీ తెలుసు కదా. So I'm skipping this part. అందరికి చూడండి. So let us take one question only, రా చూసుకోండి అందరికి. This length లేదా this area A is equals to 10 meter square. అందరికి చూడండి, this height h is equals to 8 meter. Okay, area is 10 meter square, height is 8 meters. And I'm filling some water into it till this 8 meter height. Okay, till this 8 meters of height. These are long walls, right? Okay, these are very long, no problem in it. What I'm doing now is I'm actually submerging a cube. Andariki, this is a cube. Chuskondi. Ide kada? Yes. Should I give you, should I give it to you, or I should skip it? Or I should skip it, sir. Okay. Chuskondi. A అంటే సైడ్ కదా, ఎస్. New height of water level when the cube is submerged. Completely, okay? Submerged completely. Krishna Moti, you can leave it, okay? You can leave it. Leave it, leave it. Why studying, ra? Ee mottam ante physics is boring, sir. Chemistry is boring. But leave it, leave it. Leave it. No problem. Go. Okay, padipo. If you want, take some extra snores. Okay? What is written? Hey, what is there right in all this study? Sir, we are studying 3 subjects, sir. Dintlo kuda we have 30 chapters, sir. Chala headache kada. Yes. Can any one of you tell me the answer? Huh? Choose one. The first thing is use the principle. Principle ante entira? Your volume of object must be equals to volume of displaced water. Ide kada? Volume cheppandi ra. 4 meter side unte volume is 64 meter cube. Ide kada? 64 meter cube. Right. Okay. 64 meter cube is your volume. Ante this becomes 64 meter cube. You imagine the situation wherein the cube is submerged completely. Andariki. This cube is gone. The cube is gone. And let us say the water height has increased. Ante this is your extra height. Understanding? Ante let us call this height as x. Andariki. Height is x. Height is x. Right. So if your height is x and your area is 10, what is the volume, ra? Ee volume cheppandi okasari. Only tell me this volume. Andariki. Can I say it's area into height? Ante 10x. 10x ra adi. Correct. Very good. So you can simply say, sir, your volume of the displaced water is equals to 10x, and that must be equals to volume of object, ra. Hey. So volume of object is 64, displaced water is 10x, x is equals to 6.4 meters. There you go. So your new height becomes 14.4 meters. Ide kada? Very good. Increases by 6.4 meters and your new height becomes 14.4 meters ra. Okay. చూసుకోండి. నెక్స్ట్, యూట్యూబ్ షుడ్ బి సెన్సర్డ్ కదా. ఎస్, ఇట్ షుడ్ బి సెన్సర్డ్. కాబట్టి ఐ కెనాట్ యూజ్ సమ్ వర్డ్స్. ఓకే, ఐ కాంట్ యూజ్ దమ్. మీకు కావాలంటే యూ డూ వన్ థింగ్, యూ పిక్ సమ్ వర్డ్స్ అండ్ థింక్ ఫర్ యువర్ సెల్ఫ్. ఓకే, సరే. లెట్ us talk about force of buoyancy. ఓకే, buoyant force అందరికి. Buoyant force, yes, correct. ఇప్పుడు you try to understand, okay, all of you. If this is your container, and let us say you are dipping a sphere, any object, not only sphere, okay, any object, whatever you want to dip it, you dip it, okay, something like this. Hey, you have been dipped. Try to understand. No. Yes. We'll talk about it, okay? We'll talk about it. Toxiva, we'll talk about it. Just let us go step by step, ra. Let us go step by step. Apparent weight gurinchi kuda maatlaadu. Chuskondi. Let us say this is the volume that is submerged. Volume of object. Sir, let us say the volume of object is V, ra. V ante volume of object. Ippudu chudandi. Let me directly write you the formula for your buoyant force, okay? Okay, let us directly talk about the formula for your buoyant force, sir. For your buoyant force is equals to mass of the displaced liquid, ra. Andariki chuskondi. It should be mass of the displaced liquid multiplied by G. Ade mg kada, mg ade, right. Chuskondi. Your buoyant force is nothing but mass of displaced liquid. Mass of displaced liquid ante I don't know, multiplied by G. Idigo ante you can simply say, sir, mass of liquid into G. Ide kada. Ippudu mass of liquid ela calculate cheyali ra? Can anyone of you tell me? Hi Josna, good evening. Your mass is nothing but density into volume. Ante mass of the liquid is nothing but density of liquid multiplied by volume of liquid multiplied by G, ra. Ippudu chudandi, what is volume of liquid, sir? Archimedes principle. Volume of liquid is nothing but volume of object. Ade kada? Yes. Your volume of liquid ante displaced liquid, ra. Okay, your volume of displaced liquid equals to volume of object. Ante రాసుకోండి, rho L multiplied by VO multiplied by G. ఇదిగో, this is your buoyant force, ra. The biggest mistake that student do is they either write rho L VLG లేదా rho O VOG. Okay, రెండు కూడా wrong, ra. Both of them they are wrong. Okay, the actual formula for your buoyant force is rho L VOG. అర్థమైంది? You're understanding it? Not understanding it, sir. Not understanding it. Okay, సరే. ఎప్పుడు let us talk about 9:41 కదా. Your break will be at 10:30. Okay, your break will be at 10:30 అందరికి చూసుకోండి. So let us talk about the apparent weight, sir. Yes, let us talk about apparent weight of object. Oh, nice Toxie boy, because you told me I'm taking this concept. Okay, sir. Now hey, no break up. చూసుకోండి, మీ అపరెంట్ వెయిట్ గురించి మాట్లాడాలంటే you simply understand, okay, this is your water. There are different situations, ra. Okay, actually మామూలుగా 3 cases ఉన్నాయి. I'm not taking all 3 of them. 3 cases అంటే ఏంటి రా? If your object is like this, try to understand. If this is your object, అందరికి, if this is your object, what you're doing is you are dipping it into the liquid. ఇదే కదా? Yes. First case is just like this, అంటే only the bottom is touching the surface. Different apparent mass will be there. లేదంటే if you talk about the second case, ra, మీ సెకండ్ కేసులో your object is submerged, something like this. Something ante enti, right? It's floating. And మీ third case ante చూసుకోండి, your third case is your object has completely been dipped into it. You're understanding? ఈ మూడు కేసెస్లో there will be different buoyant force. ఎందుకు సార్? Because the volume submerged is different. అంతే కదా? Yes. అంతే కదా? Right. So I'm only taking the case of this. దాని తర్వాత you can, if you want, you can do it by yourself. అర్థం రాలేదంటే you ask me, okay? I will tell you. Don't worry. చూడండి. So let us take a general case. General case ante here. Okay, here. Your object is somewhere here. అందరికి చూసుకోండి. ఇప్పుడు there are two differentiating terminologies. I want all of you to be very clear at it. Okay? సరే. You simply understand this is your density of the liquid, rho L. ఇదే అంటే density of the object, rho O. ఇదే కదా? Right. What else do we need? Volume. What volume, sir? Volume displaced. Displaced అంటే same volume. Volume of object equals to volume of liquid kada? Yes. So మీకు volume కూడా కావాలిరా. Let us say volume of object is this, VO. ఇప్పుడు in your questions the volume will not be given. They'll simply say it's a cube. The edge of this cube is 10 meters లేదా 2 meters, 5 meters ఏదైనా తీసుకోవచ్చు. Okay, right. So what you do now is చూసుకోండి. Now what you do is you try to calculate the net force. Net force ante entira? You understand, okay? Newton's laws of motion law, we have already discussed it. In your Newton's laws of motion, we have already discussed. What did we discuss, Ra? What did we discuss? We said that if there are two forces, sir, opposite direction lo rendu forces unte, what will be the resultant force? Simply the subtraction. Ade kada? Right. Chuskondi. So your mg force is acting downwards, kindaki. mg ante mass of the object into g. What about your buoyant force, Ra? What about your buoyant force? Cheppandi okasari. What can you say about your buoyant force? Andariki. Your buoyant force is acting something like this. Ide kada? This is your force of buoyancy. Andariki. Sare. Hey, try to understand, okay? Try to understand. Now, what will you talk about the apparent weight, Ra? Apparent weight gurinchi cheppandi okasari. That also depends on the conceptual topic, Ra. Conceptual topic ante enti? If you want to lift it, okay? If you want to lift it ante it's a different scenario. Leda, if you just want to weight it ante oka weighting machine teeskondi and you put it below it. You'll get two different readings. Something like that, okay? Something like that. Try to understand, everybody. Okay? Should I take it or should I skip it? I'm taking it, okay? I'm taking it. Try to understand, everybody. Andariki chuskondi. The first condition that you will be facing is cheppandi, net force is equals to mg minus force of buoyancy kada? Yes. So your mg force in the downward, your buoyant force in the upward direction. Mg ante cheppura, m ante mass of the object. Mass is density into volume kada? Yes. Sir, your mass of object is density of object, volume of object into g minus force of buoyancy. Force of buoyancy ante enti, sir? Mass of displaced liquid multiplied by g. Ante mass of liquid into g ra. Ippudu mass of liquid ante enti ra? Rho naught v naught g minus mass is malli okasari density into volume. But density of liquid, right? Sir, density of liquid multiplied by volume. Volume of what? Volume of object. Enduku, sir? Archimedes principle. Volume of object equals to volume of liquid. Ide kada? Yes. Volume of object equals to volume of liquid. Idigo v naught into g. So what you'll do, Ra? You'll simply take out v naught into g common, Ra. Okay? V naught into g into rho of object minus rho of liquid. So this is your apparent weight. Ardhamaindi andariki? Did you all understand it? Hey, don't spam, Ra. I know, okay? Don't spam. Now, there is a mistake in this method. Hey, This answer is not right, Ra. It is right. It is right only. Okay, it is right. But. You see from a deeper perspective Indira, this answer is not correct. There is a mistake. If you want to know that mistake, try it. Ledante, leave it. This is your formula, okay? Ide me formula andariki. Clear? It should not be clear. It should not be clear, sir. It's a mistake. There is a mistake. Okay? It is a mistake. Why mistake? Endugu, sir, endugu. because I don't know. Okay? You're talking about apparent weight kada. Apparent weight unte, you will not calculate the weight of this liquid. You will not calculate it. You leave it. Can't. This formula is only valid for the boundary condition. Boundary condition ante this object should touch the surface of the liquid. Then and only then this formula is valid. Try to understand. Okay, try to understand. This formula is only valid when your object is exactly touching the surface. Understanding. Try to understand. Now, let us talk about a question. All of you. Let us see how many of you can solve it. Okay, idigo. Teeskondi. Find the sufficient. Do it. Okay? Try it. Andariki. Try doing it. Sorry, you can simply do it. Okay, you can do it. No problem. How do the density of the object and the liquid affect the apparent weight? See, boy, I don't know what your name is, Ram. Okay, try to understand. I've told you two times. Ante, the first case. First case is. Where did I tell you? Hey, here, choose. If they are equal unte, this will not float. Ante, in this case, case low. your density of the liquid is rho, density of the object is rho, and the apparent weight becomes 0. Enduku sir? 0 unte it will simply float like this. Hey, not going down, not coming up, something like this. Gravity free space, something like that. Dekada? Yes. If density less unte, your apparent weight will be not till 1. Maybe the lecture will be ended by 12:30. We are left to talk about your fluid dynamics. Deentlo we will talk something about your accelerated. They do affect, Toxi boy. They do affect. For sure they do affect. So your accelerated motion slow, we have something known as fluid dynamics. Then we'll talk about your viscosity and then surface tension. Okay, the chapter will be completed. Okay, right. Cheppandi. I need the formula for the apparent weight of the object. Yes, they could have same. Okay, that's also same. But I want you to calculate the values. Values cheppandi okasari. So can I simply say, sir, a volume ante buoyant force gurinchi cheppandi andariki. Can I simply say, sir, buoyancy force is nothing but mass of the liquid displaced into G. Idigo, I am telling you from the scratch once again. Endukante I want all of you to remember the formulas from scratch only. Okay? Yes, correct. So mass of the displaced liquid ante entira, density of the liquid multiplied by volume of the submerged object, not complete volume. Okay, chuskondi. It's a very minute this difference ra. It's not complete volume. It is only the volume that has been submerged. Ante only this part of volume. Ade try to understand. Okay, volume of object submerged multiplied by G. What is density of liquid? What is volume of object ra? Volume of object is 2 by 3 pi r cube. 4 by 3 pi r cube total volume unte submerged volume is only half ra. It's only half. Ante 2 by 3 pi r cube. Hey, 2 by 3 pi r cube multiplied by G. Idigo. So you can simply say, sir, 4 by 3 pi r cube into rho G. You are understanding? Ante this is your buoyancy force. Ide kada? What about your mg ra? Mg gurinchi cheppandi okasari. Mass into gravity. Mass ante volume of object multiplied by density of object multiplied by G. Volume of object is 4 by 3 pi r cube. Density of the object is rho into G. Idigo, both are same ra. Hey, both are same. Both are same. Hey, both are same. Okay? Right. Correct. 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 అంటే ఈ కేసులో your apparent weight is 0. And I would like to suggest you, in the beginning, do some questions by this method. Direct formula, you don't use it in the beginning for some questions. Direct formula ante entira, your apparent weight, W apparent is equals to, what do you can say? V0 into G multiplied by density of liquid minus density of object. Ide kada? Finished. Okay. This formula is not valid in this question. You apply, you see, okay, let us go with this formula. Let us go with this formula. V0 value entira, V0 of object, 4 by 3 pi r cube into G. What is density of liquid, sir? 2 rho. Hey, density of object, it should be density of object, kada? Yes, density of object minus density of liquid. Hey, density of object is rho minus 2 rho. Idigo. So your apparent weight comes out as minus 4 by 3 pi r cube into G into rho, which is correct, ra? 0 is correct, or this is correct. మీరు ఫార్ములాతోనే వెళ్తే this will be the answer that you will be getting. And if you do it, this is the answer. So which is correct, sir? Formula is wrong. Is the formula wrong, ra? Cheppandi okasari. Is the formula wrong, andariki? Can you tell me about the formula? Is it correct or wrong? Which answer is correct? This is correct, or this is correct? What is correct? What is correct, Ray? Hey, cases ra. Case 1 is correct, leda case 2 is correct. We will go conceptually, okay? Ade, in fluid mechanics, you have oceans to explore. Okay? 0 is correct answer. Okay. Why not the formula? Why not this? Why not this? Why not this, ra? Why not this? Choose. Now I'll tell you something about apparent weight. Okay, choose. If you are telling that this is your apparent weight, ide kada? Idigo. When you are telling that this is your apparent weight, ante enti ra? That means what? That means what? That means what? You don't seem interested at all. Don't know why am I doing all these questions. Okay, sorry, let it be. I'm not interested in this question only. Hey, choose one. Now what we'll be doing is we'll be taking one more question. Choose one. The basic assumption, what did I say? This formula calculations, చూసుకోండి. I have told you this is also wrong. ఇదే కదా? Why wrong, sir? Why wrong? Anyways. Buoyant force అర్థమైంది, right? You understood about the buoyant force, ఇదే కదా? Yes. The question is find the buoyant force. Do it. మీకు 1st of February అంటే సండే ఆ రోజు విల్ బి టేకింగ్ ద ఎంటైర్ ఫుల్ డే మ్యారథాన్ అంటే మార్నింగ్ 9 నుంచి ఈవినింగ్ 9 నైట్ 9 వరకు విల్ బి టేకింగ్ కంప్లీట్ యువర్ మోడర్న్ ఫిజిక్స్. విల్ ఫినిష్ యువర్ మోడర్న్ ఫిజిక్స్ ఇన్ దట్ లైఫ్. ఓకే, ఏయ్ యువర్ buoyant force రా, వై ఆర్ యూ గెటింగ్ సో లేజీ? అందరికి చూసుకో, a/3 హైట్ కదా. వాట్ అబౌట్ దిస్ సైడ్ సార్? ఏ అంటే వాట్ అబౌట్ ద బేస్ ఏరియా రా? ఇట్స్ అ క్యూబ్ అంటే యువర్ బేస్ ఏరియా ఇస్ a square. a square ఇంటూ a/3 అంటే a³ by 3 కదా. ఎస్. సో ఇప్పుడు యూ క్యాన్ సింప్లీ సే సార్ ఆబ్జెక్ట్ లేదా వాల్యూమ్ ఆఫ్ సబ్మర్జ్డ్ ఆబ్జెక్ట్, నాట్ ఓన్లీ ఆబ్జెక్ట్ రా, వాల్యూమ్ ఆఫ్ సబ్మర్జ్డ్ ఆబ్జెక్ట్ should be equals to a³ divided by 3. ఇదే కదా. అంటే this will be the volume of the liquid displaced. అంతే కదా. So you can simply say sir your force of buoyancy is nothing but density of liquid multiplied by volume of object submerged, not complete volume. అందరికి ఇదే కదా. This is a small thing that you have to take care of. Multiplied by g. ఇదిగో density of liquid అంటే rho, volume of object is a³ by 3 multiplied by g. ఇదిగో. So this is your buoyancy force. అందరికి. Will it change as you dip it? Yes, it will change. It will change. It will change. It will change. Okay? It will change. ఏం పేరు రా? ఏం పేరు కావాలరా చెప్పండి. So if I ask you plot graph of buoyant force FB versus height submerged, ఇదే కదా. yes, height submerged. అంటే if you are dipping it slowly how will the buoyant force change? ఇదే కదా. how will the buoyant force change? How will the buoyant force change? How will it change? Can you tell me ra? Can you tell me? So let us say, hey andariki, this height is x. Ante kada. In the beginning the value of x was 0. Ante when it was not submerged, ante x equals to 0 nunchi it came at x equals to a. Idi gora. What about the volume sir? When it was x is equals to 0, your submerged volume was 0. When it was x equals to a, your submerged volume was a³. కానీ ఒక జనరల్ పాయింట్ లో కెన్ యూ టెల్ మీ వాల్యూమ్ ఇస్ ఈక్వల్స్ టు, కెన్ ఐ సింప్లీ సే సార్ a² ఇంటూ x? ఇదిగో ఎస్, a² అంటే ఏరియా ఆఫ్ బేస్, x అంటే దిస్ ఈస్ ద డెప్త్ లేదా ద హైట్ దట్ హ్యాస్ బీన్ సబ్మర్జ్డ్. అదే. సో ఇఫ్ యు ఆర్ టాకింగ్ అబౌట్ ద గ్రాఫ్, దిస్ ఈస్ యువర్ buoyant force FB, దిస్ ఈస్ ద హైట్ x బిలో ద సర్ఫేస్. ఓకే, బిలో సర్ఫేస్. ఇదిగో. If you talk about it ra, చెప్పండి, this is volume కదా. yes, buoyant force is equals to density of the liquid multiplied by volume submerged sir, a² into x multiplied by g. ఇదిగో. can I simply say sir force of buoyancy directly proportional to x? అంటే this is a graph. It will increase linearly ra. right. So it's a straight line that is starting from x is equals to 0 and the value, maximum value is x equals to a. ఈ వాల్యూలో యువర్ buoyant force will be, చెప్పండి, rho a³. కరెక్టా? ఎస్, గుడ్. ఇప్పుడు let us talk something about your Pascal's law. What do you mean by your Pascal's law, sir? Right, correct. Your Pascal's law statement వినండి. ఓకే, ఎనీ చేంజ్ ఇన్ ద ప్రెషర్ ఆఫ్ an incompressible, okay, for this you need an incompressible ra, for an incompressible liquid, okay, liquid at any point travels లేదా should I say travel? No, I should not say travel. Gets distributed. You should also say travel, okay? Gets distributed entirely into the liquid. Other. What did you write, sir? We did not understand anything. We did not understand anything. Write it. Don't worry. Okay. Pressure act at right angles, sir. What do you mean by pressure acts at right angle? This is the law, Pascal's law. Any change in the pressure of an incompressible liquid at any point gets distributed entirely into the liquid. And try to understand. If this is a piston, should I say piston? Yes. You can simply say this is a piston. Okay. Sorry. Leda injection తీసుకోండి, okay? Injection. Okay? Syringe. All of you are familiar. కదా? So this is a syringe, అందరికి. And let us say this is a piston. Try to understand, okay? Try to understand. Ide me liquid. This is your liquid. Ade kada? Right. Modatiga, there was no pressure or no force on this liquid. It was normally as it was moving. Okay? Kani, now what we are going to do is we are going to apply a small pressure P0. Idigo. You are going to exert a small pressure P0 into this liquid. Eppudu emaitadi ante not on wall. Okay, sorry. Yeah, I understood. If you exert small pressure P0, what will happen is, hey, you are exerting this pressure with one more piston, okay? You have a small size piston, చూసుకోండి. This is a small size piston. You are pushing this piston inside. ఇప్పుడు ఏమైతుంది అంటే that extra pressure P0 that you have introduced, అందరికి చూసుకోండి. This pressure actually gets distributed at each and every point of this liquid. ఇదిగో, something like this. You are understanding? This pressure P0 travels all the way in each and every point of this liquid. This is simple Pascal statement. అర్థమైంది? Right. Okay, so if this is your extra pressure P0, you have just applied the extra pressure P0 over here. What's happening is this P0 is traveling entirely into the liquid. You are understanding? And you should not say on the walls of the syringe. It travels at each and every general point. There are liquid molecules, kada? Something like this. You push only a single molecule, only a single molecule. This single molecule will create the chaos, earthquake, and it will push each and every molecule. And the same push travels entirely into the liquid. Ante the liquid, ante incompressible liquid does not keep anything. Ante it does not absorb anything. You are understanding? Whatever you push, the pressure you gave, later you can take it whatever you want. ఈ మొత్తం pressure, it will be distributed, లేదా it gets traveled into the entire liquid. You are understanding? Yes. So what happens now is, due to this pressure P0, you exerted it from the outside, kada? Yes. The effect of this pressure will be seen on this wall also. అర్థం చేసుకోండి. Try to understand. ఇదే కదా? Right. సరే. Now, we will take an example. చూసుకోండి. Example అంటే ఇదే. So this is your container. Okay, let us say this is a face. Face అంటే opening రా. This is another face అంటే another opening అందరికి. Visualize చేసుకోండి. Okay, it's something like this. Its shape is something like this. Now what we are doing is, జాగ్రత్తగా వినండి, all of you, try to understand. Okay, we are filling it with an incompressible liquid. Okay, we are filling it with an incompressible liquid. Hey, it's not something like this. There are sections to it also. చూసుకోండి. It is getting actually transfer something like this. Okay, it is actually a part of the system that I have told you. అందరికి జాగ్రత్తగా వినండి. Okay, now what happens is, try to understand, everybody. Let us take a small time interval dt. చిన్న time interval dt తీసుకోండిరా, and you say the velocity of the liquid is v. అదే కదా? Yes. The question is, will the velocity be same at all the points? Will the velocity be same at all points? Statement number 1. When you have when you have a moving liquid. Am I taking correct example, Ra? Am I taking correct example? No, I should not say something like this. Just one. Okay. I'm actually extending this form. It gets too complicated if I tell you like this. Just go. So let us do one thing. Right? This is a syringe, okay? Syringe and it's a piston. This is also your piston. Try to understand. Okay? Let us say this area is A1 and let us say this area is A2. ఇదే కదా ఇప్పుడు చూసుకోండి అందరికి. Let us say you are applying a pressure P, pressure, not force, pressure అంటే తెలుసా, force upon area. Try to understand. If you are applying this pressure P, ఏమైతుంది అంటే ఈ మొత్తం pressure it will get uniformly distributed at each and every point of this liquid. అదే కదా, it will travel everywhere. ఎక్కడ కూడా it will be P only, P. So if you want to balance this external pressure, you should apply the pressure something like this. ఇదే కదా. What should be that pressure? ఈ pressure కి వాల్యూ చెప్పండి ఒకసారి. అరే ఇది కూడా P. ఎందుకంటే సార్, if you are applying a pressure P from this side, it will go. P from this side, it will go. They will hit and they will cancel out one another. అదే కదా. P from this side, travel, cancel out. అదే finished. అంటే if this is pressure P1, this is pressure P2 రా. ఒకటే కండిషన్ అంటే P1 upon P. P1 should be equals to P2. Pressure అంటే force upon area. అదే కదా. Yes. Pressure P1 చెప్పండి రా ఒక్కసారి. That means if you are applying force F1 here, you are applying force F2 here, you can say sir, pressure is force upon area must be equals to second force upon second area. ఇదిగో. This is the equation. And this is very important equation, okay? Try to understand. This equation is very important. చాలా important equations. చూసుకోండి. Next, let us talk about hydraulic lift. It's a simple principle based from your Pascal's law. Hydraulic lift. And what do you have in a hydraulic lift, sir? You have the setup something like this. Okay. ఈ సెటప్ లో యూ ఫిల్ ఇట్ కంప్లీట్లీ విత్ అ లిక్విడ్, ఇన్కంప్రెసిబుల్ లిక్విడ్. ఇదిగో అర్థం చేసుకోండి. ఇఫ్ ద లిక్విడ్ ఇస్ కంప్రెసిబుల్, నథింగ్ హోల్డ్స్ ట్రూ రా. దేర్ విల్ బి ద పొటెన్షియల్ ఎనర్జీ ఆఫ్ ద లిక్విడ్ ఆల్సో. వీఆర్ నాట్ గోయింగ్ ఇన్ టు ద టెక్నికల్ డీటెయిల్, ఇట్ ఈస్ టూ మచ్ డెప్త్ కదా, నాట్ గోయింగ్. చూసుకోండి. ఇఫ్ దిస్ ఇస్ ఫిల్డ్ విత్ అ లిక్విడ్, అందరికి ఇఫ్ దిస్ ఇస్ ఫిల్డ్ విత్ లిక్విడ్, ఏమైతుంది సార్? వాట్ విల్ హ్యాపెన్ సార్? ద లిక్విడ్ ఇస్ సంథింగ్ లైక్ దిస్. ఇప్పుడు డూ వన్ థింగ్, క్లోజ్ ద లిడ్స్ రా. Close the lids. So this is the lid. Dekh kada? Yes. Close it. The lid has been closed. You are putting the lid ra. Ekkada kuda close the lid. Cheppandi andariki. This lid is something like this. Ante kada? There is this liquid. Ippudu let us try to understand, okay? Area A is equals to 1000 meter square. 1000 meter square ante it's a very large area. Ante kada? It's a very large area. And here let us say the area A is equals to, what should I say ra? 1 centimeter square. It's a very small area, okay? Chala chinna area, and this is a very huge area, okay? Sir, ippudu the biggest question I have is, let us do one thing. Andariki జాగ్రత్తగా వినండి. ఈ ఏరియా అంటే 1000 మీటర్ స్క్వేర్. Let us park our car ra. Mercedes, BMW, tell me a heavier car. Rolls Royce, not heavy. Fortuner ra. Fortuner. ఇదిగో. So this is my Fortuner andariki. Not a Fortuner ra. Let us take a bus. లేదా train ra. Train. This is the train andariki చూడండి. So this is a train. This is a train ra. What is the mass of the train? Cheppandi okasari. So let us say mass of train is equal to 1000000 kg. Ade ante kada? Very high. This is the mass. Enta zeros ra? 2 4 6 zeros. 6 zeros ante million ante 10 lakh kgs, okay? 10 lakh kgs is the mass of this train. ఇప్పుడు when you put this strain on this lid రా ఏమైతుంది సార్, it will go down mg కదా, go down అంటే it goes down, it goes here, it goes up. Understanding? It goes down, it goes here, it goes up రా, up. మరి నాకు బ్యాలెన్స్ చేయాలి కదా. సో బ్యాలెన్స్ చేయడానికి what you do is you exert some extra force F. ఇదిగో ఫైండ్ చేసుకోండి రా, what should be the value of that force. అదే you are understanding. What should be the value of the force F that should be applied such that this entire train gets balanced. అర్థమైంది? చెప్పండి ఒకసారి. సింపుల్ ఫార్ములా రా, F1 upon A1 equals to F2 upon A2. ఇదే కదా. F1 వాల్యూ చెప్పండి ఒకసారి. 6 zeros is only mass. mg అంటే 1 more zero extra, add it. F1 అంటే 1 2 3 4 5 6 7. ఏరియా చెప్పండి ఒకసారి. ఏరియా is 1000 meter square. 1000 meter square అంటే ఏరియా is 1000 అందరికి. Should be equals to F2 divided by, ఇప్పుడు ఒకసారి ఏరియా చెప్పండి. ఇట్స్ 1 centimeter square. 1 centimeter square అంటే ఎంతరా? 1 centimeter square. Sir, your area 1 centimeter square should be equals to 10 to the power minus 4 meter square. ఇదే కదా. రైట్. సో 10 to the power minus 4 meter square, ఇది కూడా మీటర్ స్క్వేర్ కదా. ఎస్. 3 zeros gone. How many zeros left? 1 2 3 4. ఎక్కడ? 10 to the power minus 4. Do the cross multiplication రా. అంటే 1 2 3 4 into 10 to the power minus 4 is equals to F. అంటే gone. You only need 1 Newton of force రా. Oh my goodness. అంటే you put it 1 million kg of train in the side and here you only put 100 grams of block ra. Idigo 100 gram of block chalu. This 100 gram will balance this entire 1 million kg of train. Understanding? 0.1. How can you? 1 Newton only ra. 9.8. What you are telling, sir? Chuskondi. This is hydraulic press. Ante ఇప్పుడు if you press it by 2 Newton force, if you press it by 2 Newton, ఏమైతుంది అంటే this train will get lifted up. Understanding? Right. If you put it, లేదా if you push it by 2 Newton, 3 Newton, 4 Newton, automatically this train gets lifted up. So understanding? Yes. So hydraulic lift అంటే it does not operate on electricity. చూసుకోండి. What happens is you only have a single switch రా. ఆ స్విచ్ తోనే you operate millions of kgs of the masses. Cranes, me complete cranes. Your JCBs all operate on a single principle. Basic principle ante ide. Clear? Not clear? Good. So that means your Pascal's law has been completed. Ide kada. What's the time ra? Let us take a break at 10:30 andariki. Right. Now let us talk something about your accelerated fluids ra. Chuskondi. Let us talk something about your accelerated fluids. I'm writing a golden statement, okay? I'm writing a golden statement. Golden statement ante let us write in golden color. It's a golden color kada? Yes. The layers. It's a very important statement andariki, okay? The layers of a liquid are always the layers of a liquid are always. Cheppu, can any one of you fill this statement ra? The layers of this liquid, the layers of a liquid are always perpendicular. Idigo, are always perpendicular to the net you forget your name, does not matter, and you don't forget it ra. You are understanding? You are forgetting your name, I don't have any problem, but don't forget this statement. చూసుకోండి. అంటే నెట్ యాక్సిలరేషన్ అంటే ఏంటిరా? ఇప్పుడు you need Newton's laws. Okay, now you need Newton's laws of motion. చూసుకోండి, if this is your liquid, చూసుకోండి all of you, this is your liquid కదా, it is completely relaxing on a normal conditions. అంటే at rest net acceleration is only g, net acceleration is only g. ఇదిగో, so your net acceleration is acting only in the downward direction. అంటే your net acceleration is only g, and your layer is always perpendicular to the net acceleration. ఇదే కదా, all the layers. Okay, if the liquid is not moving within itself, try to understand, there is a difference between, where did I write? Okay, there is a difference between your accelerated fluids. Okay, there is a difference between your accelerated fluid and your moving fluid. మీ accelerated fluids లో, try to understand, in your accelerated fluids, once the acceleration has been completed, hey, and at the same time we'll be talking about constant acceleration. Okay, ante the acceleration will be constant ra. Try to understand, you're talking about constant acceleration. Variable acceleration unte I would not say this. Okay, if the acceleration is variable, I would not say that the fluid is not moving. Try to understand. Okay, your accelerated fluid ante, once your acceleration has been achieved, the molecules take a stationary position. ఏమైందిరా, what am I telling? జాగ్రత్తగా వినండి. ఒకసారి your acceleration has been completed అంటే molecules will take their own stationary position. కానీ మీ మూవింగ్ ఫ్లూయిడ్స్ లో the molecules are continuously moving. Something like this. Washing machine లో if you are putting some liquid ra, try to understand, it is rotating కదా. Yes, so the entire liquid is rotating. Ante that becomes your moving fluid. Every molecule is rotating. లేదంటే you take a bucket full of water, put your hands, ante kada, every particle is moving. Try to understand, you are not disturbing the flow ra, you are disturbing the flow. In what, sir? In moving fluids case ra. Kani me accelerated fluids lo, the molecules are stationary with respect to one another. Okay? This is the biggest difference. Andariki chuskondi. Now మొదటిగా your acceleration was 0 ra, no problem, everything was calm, silent, slow, soft, steady. అదే కదా. Now we are going to create an earthquake. ఓయ్ 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 ఓయ్, చూసుకోండి. Am I doing correct? Not like this. Something like this. Hey, so this is your container. ఇదే కదా. Yes. Let us say initially the layers were horizontal. అంటే your acceleration was 0. ఇప్పుడు I am accelerating it. I am giving some acceleration. చూసుకోండి. A is the acceleration. Right? A is the acceleration. ఇప్పుడు ఏమైతుంది అంటే this layer, due to pseudo force. Yes, pseudo force. There was a concept in Newton's laws. There was a concept in your Newton's laws, pseudo force. Ante when you move this truck aside, emaitidi, these layers will get aligned. Ante how, sir? Something like this. Right? Not like this. Right? I'm getting too much. Something like this. Idigo. You are understanding? The layers are shifting backwards. Ardhamaindi? Yes. ఓకే, రైట్. సో ఈ కేసులో ఈ ఫార్ములా ఒక్కసారి గుర్తుపెట్టుకోండిరా. వాట్ ఇస్ ద ఫార్ములా అంటే స్టేట్మెంట్, ద లేయర్స్ ఆఫ్ లిక్విడ్ ఆర్ ఆల్వేస్ పర్పెండిక్యులర్ టు ద నెట్ యాక్సిలరేషన్. ఈ కేసులో ఇఫ్ దీస్ ఆర్ యువర్ లేయర్స్, అందరికి ఇఫ్ దీస్ ఆర్ యువర్ లేయర్స్, ట్రై టు అండర్స్టాండ్. యాక్సిలరేటెడ్ మోషన్ కదా. కెన్ యూ టెల్ మీ అబౌట్ నెట్ యాక్సిలరేషన్ రా? పర్పెండిక్యులర్. Hey, this will be your A net. ఇదిగో కదా. Your layers are always perpendicular to the net acceleration. If it's a accelerated fluid, ade. Ledante it's a stationary fluid, ade. The same principle holds good. Whenever you see your layers inclined, ante your acceleration will be perpendicular to the layers. try to understand. Okay, sorry. So now let us talk about the acceleration. Andariki chuskondi. This is your liquid and the container moving with an acceleration A. Due to this acceleration, the shape of the liquid has changed like this. It came down kada? Yes. Correct. ఇప్పుడు నాకు net acceleration కావాలి కదా? So you can simply say, sir, your net acceleration అంటే take a normal point on the surface. Normal point on the surface తీసుకోండి. Sir, mg was acting downwards కిందకి. Force force, it's a force kada? లేదా you write the acceleration only. For acceleration there will be g only ra. And if the acceleration is a, మీ pseudo acceleration చూసుకోండి అందరికి. Your pseudo acceleration will be towards the left. What is the value, sir? G. ఇప్పుడు net acceleration గురించి మాట్లాడాలంటే you will simply say your net acceleration will be between the two. ఇది నా net acceleration వాల్యూ ఏంటి సార్? A net acceleration is root of a square plus g square. ఇదే కదా? Yes. ఒక్కసారి యాంగిల్ గురించి చెప్పండి సార్. ఏం యాంగిల్ రా? The angle that is made with this theta. ఇదే కదా? Yes. Theta. Hey, did I write g? It should be a, okay? It should be a ra. Yes. Sir, tan theta formula చెప్పండి సార్. Tan theta అంటే opposite side చూసుకోండి. Opposite side by adjacent side. Opposite side ఎంత సార్? Tan theta is equals to opposite side is a divided by g. ఇదిగో this. This is the formula for a tan theta. అంటే your acceleration if a closed container is accelerated horizontally and the pressure at the front top corner drops, no, vacuum will not be created. Endukante the entire volume inside the flask remains the same kada? Yes. So if you have a closed volume, if you have a closed object, this is your liquid kada? So what's happening is when you are accelerating it, the liquid layers are getting shifted like this. You talk about air, okay? Air. This was the extra place occupied. The air of this place has gone. Air is gone. This was air and liquids came up. Where is it gone? The air has gone. The air has gone in this place. It travels from this to this point. No vacuum is created. Volume remains constant. Right? No vacuum is created. Very good question actually. Chala manchi observation. So once we are done with it, okay, can we take a break now? Let us take a break. I did not eat anything, okay? Give me some time to eat. Sorry. We'll not take much break, only half an hour. Your chapter is complete. Okay? 2.5 hours are completed kada? Yes. Sorry. hello అందరికి హాయ్ సారీ ఎలా ఉన్నారు అందరికి చెప్పండి యార్ 3 minutes లేట్ రా దయచేసి క్షమించండి ఎందుకంటే there were some important discussion going on సరే ఓకే 11:04 kada yes so if we end it by 12:30 we only have 1 hour 30 minutes left ra sare let us cover it quickly andariki chuskondi so modatiga we'll talk about your fluid dynamics ante moving liquids okay moving liquids లేదా liquids in motion okay first let us talk about your fluid dynamics ante kada yes so this is your fluid dynamics చూడండి fluid dynamics లో సాధారణంగా if a cylindrical container of liquid is rotated about its vertical axis what is the shape of the free surface the shape of the free surface looks like a parabola okay parabola the surface looks it's not there in your syllabus ra okay it's for JEE the parabola is there and the equation also it also has yes Parimala correct we will have to increase the speed okay we will discuss everything ra what is viscosity and all these things don't worry okay don't worry anyways let us see over here చూసుకోండి fluid dynamics లో సాధారణంగా మీ దగ్గర ఒక 2-3 ఫార్ములాస్ ఉన్నాయి రా the first one is the equation of continuity దాని తర్వాత we will talk about your Bernoulli's equation okay దాని తర్వాత we will talk about Bernoulli's equation saying something సరే let us talk about equation of continuity అందరికి చూసుకోండి Malli I am making you realize that whatever we are discussing, why you don't go into all of that. You're not a JEE aspirant, okay? I will not see. Fluid mechanics is the easiest chapter for NEET aspirants. Easiest chapter, easiest. And fluid mechanics is the toughest chapter for JEE students. And your fluid mechanics is not as simple as it appears, ra. Okay? Try to understand fluid dynamics law whatever liquid we are taking that fluid is an incompressible fluid okay incompressible fluid this is the biggest issue later the biggest statement that you have to remember okay if at all your liquid is not incompressible nothing holds good nothing holds good you are understanding sir good oh okay you're not NEET aspirant then let us discuss it some other day ra let us discuss it some other day చూసుకోండి let us say you have a shape అంటే container the container looks something like this అందరికి చూసుకోండి you're understanding yes try to visualize okay let us say the heights are negligible heights okay people try to understand andariki and let us say there is a liquid ee container lo you have a liquid and this liquid is actually moving with a constant speed I should not say constant speeds variable speeds are there okay variable speeds andariki chooskondi so this liquid is moving at each and every single point if the area is same try to understand if the area is same 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 the speed is same and if the area is not same speed is not same ade kada try to understand చూడండి let us say the speed of the liquid is v1 ఈ కేస్ లో అంటే మీ ఏరియా a1 స్పీడ్ v1 ఈ కేసులో your area let us say that is a2 and your speed let us say that is v2 అందరికి చూడండి ఇప్పుడు కన్సిడర్ అ వెరీ స్మాల్ ఇంటర్వల్ ఆఫ్ టైం dt. ఓకే, కన్సిడర్ అ వెరీ స్మాల్ ఇంటర్వల్ ఆఫ్ టైం dt. ఈ dt టైం ఇంటర్వల్ లో యూ అండర్స్టాండ్, ఓకే, దిస్ లేయర్ ఆఫ్ ద లిక్విడ్ దట్ వాట్ ఎవర్ ఇట్స్ దేర్, లిక్విడ్ కదా, ఇట్ ఈస్ మూవింగ్ అహెడ్. అంటే కొంచెం సమయం తర్వాత ఆఫ్టర్ టైం dt, అందరికి చెప్పండి, స్పీడ్ v1 కదా, టైం dt రా, కెన్ యూ టెల్ మీ ద డిస్టెన్స్ సార్? సార్ ద డిస్టెన్స్ ఇస్ v1 into dt. ఇదిగో సార్, understanding? Yes. Similarly, you come here and look at it. Similarly, you come here and look at it. Okay? You come here and look at it. What will happen here is, try to understand. Speed v2 kada, ade dt time lo, what will happen is, this layer of the liquid, whatever it's there, this layer of the liquid in time dt, it will cover some distance. What distance ra? v2 into dt, ide kada? Yes sir, v2 into dt. ఇప్పుడు చూడండి అందరికి, ఆల్ ఆఫ్, ఓకే, ఫోకస్. Let us consider the volume of the liquid రా, చూసుకోండి, this volume. If this volume is v, try to understand, all of you, మీ dt టైంలో if v volume is entering into the liquid and the liquid is incompressible liquid అంటే ఏంటిరా? You cannot compress it, అంటే whatever you are pushing, same volume should be exiting, అదే కదా? Yes. Whatever volume is entering, the same volume should be exiting ra. Endukante it's an incompressible liquid. You cannot store the liquid into it. Everything full kada? Yes. So if you want to insert one more, you have to remove one. Ade. So the same volume V is this also ra. Chuskondi. Volume V. Leda V1 and V2 pilustaru. You will simply say, sir, V1 should be equals to V2. Ade kada? V1 value cheppandi ra. Sir, volume is area into length. Area ante A1 ra. Area is A1. Length how much sir? Length is V1 dt. Yes, V1 dt should be equals to E volume. Cheppandi okasari V2 volume. Sir, area malli okasari, area is A2, length is V2 dt. Ade. So it is A2 into V2 dt ra. Hey, dt gone. That means you can simply say your A1 V1 should be equals to A2 V2. This equation is known as equation of continuity ra. Idigo. Finished. This is known as equation of continuity. Ide kada? Yes. Appudu you might be asked different formulas. Try to understand. Okay? Try to understand, everybody. Should I say ra? What should I say? Okay. Let us directly jump on Bernoulli's equation. Okay, I'm not going into the proof because we don't have much time left. Let us jump to Bernoulli's principle, లేదా Bernoulli's equation. I'm really sorry, I have to leave a lot of things. Okay. Yes, dynamic fluids. It is only the dynamic fluid question. If you want, we can take some questions out of it, and I don't think it would be appropriate to take it now. And there are some questions that are directly asked. Just formula good petkondi. Ippudu chuskondi. Now let us talk something about your Bernoulli's principle. Okay. Bernoulli's principle is applicable. చూసుకోండి, 3 factors ఉన్నాయి. First one is difference in height of the liquid. ఇదే కదా? Yes. The first condition is the liquid must be a moving liquid రా. ఇదిగో. The first condition is it should be a moving fluid. And you can understand your gases also, they are fluids kada? Yes, try to understand. They are gases also, they are fluids రా. ఇప్పుడు చూసుకోండి, conditions చూసుకోండి. The first condition is there should be difference in the heights. This is your first condition. దాని తర్వాత the second condition should be, చెప్పండి, your liquid is moving. ఇదే కదా? Yes. It's easy, but you know, it's not easy, ra. Have to understand some things actually about it. Okay, there should be difference in heights and difference in areas also. So you will have to construct a pipe, ra. Chuskondi. This should be your hey, I don't have to join it, huh? Something like not like this, right? Hey, too much irritating, ra. Like this. It's like something like this. It's a pipe. It's a pipe, ra. This is your pipe. Okay. And last condition, ra. Last condition. Chuskondi. Last condition ante the liquid should be incompressible. Ide kada? Yes. Now, let us try to analyze this entire system from some frame of reference. And this entire frame is at a height h above the ground. This is my ground. Andariki chuskondi. E height and let us say this height is h1 and the height of the other end of the pipe chuskondi. This height is h2. Ide kada? Yes. The pipe does not cut, right? It is not cutted. The liquid is actually flowing, okay? Ide ma liquid. Ippadu kosam just good petkondi, okay? Just remember this formula. What does the formula say, sir? Let us say the speed is v1 and let us say the speed is v2. Ide kada? 1 minute. And the pressure is P1 here, the pressure is P2 here. Formula good petkondi. There are three factors, okay? Three factors. The addition of three things should be constant. Number one, pressure plus kinetic energy term, half rho v square plus rho gh, mgh term, gravitational potential energy, rho ante density of the fluid kada. It must be same. These three things should be constant. Ante P1 plus half rho v1 square plus rho g h1 should be equals to P2 plus half rho v2 square plus rho g h2. Just remember the formula. The proof is not required for you until and unless you are preparing for IP era. Okay, sorry. Yes, we are not artists. Yes. This is your Bernoulli's principle. What will happen if your height is same? If your height is same, ante at constant height, So let us take the example of a constant height, something like this. Kani the cross section area should be different, kada? Yes. So let us say this is your container. Something like this. Ide kada? Yes. Ippudu cheppandi. Your heights are not that significant, and your heights are approximately on the same level. These are your heights, kada? I should skip it. Something like this. This is your container. So these are your heights, okay? Not much difference. Mari, what can you say, You can simply say, sir, P0 plus half leda P1 kada? Yes. So you can simply say, sir, P1 plus half rho v1 square plus rho g h1 should be equals to P2 plus half rho v2 square plus rho g h2. Idigo h1 equals to h2 Gone. Mari, you are left with this equation. P1 plus half rho v1 square should be equals to P2 plus half rho v2 square. Ante entira, you try to understand, okay? Try to understand. If you have two numbers, 3 plus 7, entara 10 kada? Yes. If you try to increase one number, let us say you are increasing it to 5. But what should be the value of 7? And if you are increasing one number, the other must decrease. Choose. Understanding? If your speed is high, pressure will be low. If your speed is low, pressure will be high. Ide kada? The applications of your Bernoulli's principle are huge. Chuskondi. The best example would be the example of a train. This is your train, ra. This is your train track, kada? Yes, let us say this is your train that is coming on the station. Something like this. Chuskondi. But what happens is, you know about the platform, kada? You know about the platform, andariki. Cheppandi. This is your train going something like this. This is a person, ra, standing close to the train. Emaitadi, sir? The air. Chuskondi. The air, kada? Yes, the air near the train. Ante this air, ra. These air particles. If the train is moving, these particles also move with the train. Ante speed is high, ra. Chuskondi. Speed high unte pressure should be low, kada? Yes, the pressure should be low. Ante ee region low, your pressure is low. And what about the other region, sir? Other region ante enti ra? This region, this entire region. The entire region low, this is your person, huh? This is your person. The entire region low, your speed is low. Ante your pressure should be high. Ippudu chuskondi. Here is high pressure, here is low pressure. What happens, ra? Things move from high pressure to low pressure, kada? Yes. So this pressure difference creates, it pushes you to the train itself. Kabatti, it is not advisable. You see on the railway tracks, they have some colored tracks, kada? You are not suggested to go beyond it. Endukante if the train is moving fast, the air is moving fast. If the air is moving fast, that side air is not moving. And pressure is high over there. Here pressure is low. You will be pushed towards the train. Hey, something like this. Sorry. Similarly, your aeroplanes also, chuskondi. Me aeroplanes kosam, these are your wings of the aeroplane, kada? Something like this. If you see the cross section of an aeroplane, the wings look something like this. This is your aeroplane, ra, andariki. Try to understand. This is your aeroplane, kada? These wings are coming out. Something like this. Something like this. So, if you see the air, andariki. Try to understand. If you see the air particles that are there, as the plane is moving, the upper particles, choose the upper particles and the red color particles. What's happening is these upper particles have to cover this entire distance and come here. What about the lower particles? The lower particles, they are simply covering this much distance. Can you tell me which distance is more? Either x1, this is x2. x1 is greater than x2. And speed of the upper particles, v1, it should be greater than v2. So if speed is high, pressure should be low. Speed is high, pressure should be low. And it is your pressure P1, here pressure P2. And your P1 should be less than P2. Ra. Choose one. High pressure to low pressure. The plane gets pushed up in the upward direction. And this is how your planes move. Okay? Something like that. Try to understand. Okay? Try to understand. Anyways, this was all about your Bernoulli's principle. Okay? I'm saying something. What are the topics left now? Let me just quickly go through your curriculum. But I don't want to teach something more. Okay, sorry. Okay, viscosity is left. Sir, so let us talk about this. But before that, try to understand. Okay, try to understand. In this scenario, if you have your fluid moving something like this, try to understand. Okay? In case lo, if at all your fluid moving like this. So now what we'll do is, yes, what's the doubt, Ra? Chippandi. What is the doubt? What is the doubt? May I know the doubt? May I know the doubt? All of you, try to understand. Okay, try to understand. If the speed is v1 here, in e case lo, your speed over here is v2. Ide kada? Speeds gurupettukondi. If v1 is here, v2 is there. What do you think? Which speed will be greater, sir? What speed will be greater? Cheppandi andariki. What speed is greater? v1 greater or v2 greater? v2. Enduku, sir? Equation of continuity. Equation of continuity. Ide kada? So you can simply say, sir, If V2 is greater than V1, pressure గురించి చెప్పండి రా. Bernoulli's equation కదా. If your pressure is high, speed should be low. If your pressure is low, speed should be high. ఇదే కదా. Yes. ఇక్కడ చూడండి. If your speed is high, here, speed is low కదా. అంటే ఈ పాయింట్ లో pressure is high రా. And here the pressure is low. ఇదే కదా. Yes. The pressure is high and pressure is low. ఇప్పుడు if I attach, if at all I attach tube, చూసుకోండి, tube. If at all I am attaching a tube, something like this. And here also, if I am attaching a tube, అందరికి. So what will happen, sir? The liquid will flow up. It will go up because it has pressure, high pressure కదా, and pressure is in all the directions రా. కాబట్టి ఈ కేసులో your pressure will be more అంటే the height attained by the liquid will be more. ఈ కేసులో your pressure is low అంటే the height attained by the liquid is low. You are understanding? Yes. So what is the difference between the heights, sir? Let us say this height is h2 రా, h2, and let us say this height is h1 రా అందరికి. ఇదే కదా. What can you say? Sir, extra pressure difference is simply equals to rho g h, rho g delta h. Okay. You are understanding well. లేదంటే it's a Venturi meter, okay? Venturi meter. అదే. I don't want to spend much time on all these things రా. చూసుకోండి. Now let us talk something about your, and there is a case రా. If you want me to discuss, I'll discuss it. చూసుకోండి. What will happen is, if at all you have a pipe, okay? If this is your pipe అందరికి, and the water is actually coming out from this pipe. Okay, let us say the speed of the water is V. Andariki. Density of the liquid is rho. Density of the liquid ante rho. Speed is V. Area of the cylinder, the area of the surface is A. Now chudandi, I want to talk about when you hold the water, what happens? It will recoil kada. It will recoil. You turn on the pipe, it will recoil ra. Ante the reaction force is exerted by the water on the pipe. Ide kada. Yes. If the liquid is along the horizontal incline, the relationship is this. Idigo. The relationship is this. Until the sum of your pressure and kinetic energy remains the same. Ide kada. Hey, anyways, try to understand. Okay? What should be the reaction force exerted by the liquid on the pipe? Okay? That is the question, Andariki. What should be the reaction force exerted by the liquid on the pipe? Let us talk about 1 second terminology, okay? 1 second, Ra, 1 second. Try to understand. First of all, in 1 second time, okay, Andariki, in 1 second time, can you tell me, can I simply say, sir, your force is nothing but delta P upon delta T, idigo. Delta P ante mass into change in speed, ra. Ide kada? Yes. So mass ante enti ra? Density into volume multiplied by speed divided by delta T. Delta T is 1 second. 1 second. Choose. In 1 second, what is your density, ra? Rho itself. What is the volume, sir? Volume is nothing but area into displacement. Kani oka second unte your displacement is equals to the speed into time kada. 1 second తీసుకోండి, right? Is simply equals to V. ఇదే కదా? Yes. This is your displacement. అంటే area into displacement multiplied by V divided by time is 1. So that means the reaction force exerted on the pipe is simply equals to rho A. Keep this in mind. Okay? Keep this in mind. Try to understand. A ante area, okay? Area of the pipe. There have been questions, literally the questions, ra. These questions are asked in Newton's laws of motion. Okay, a pipe of the cross section area 0.5 centimeter square has a pipe having the speed V equals to 10 meter per second. The density of the liquid meeku telusa kada, water density ra 1000 kg per minute. Find the force. You are understanding? Something like that. The questions are asked. Good pettukondi ee formulas. Let us talk about your viscosity. We have 1 hour time ra. Enduku inta, I don't want to do any hurry, you know. Okay, we have viscosity and then we have surface tension, Ra. Okay. Let us quickly talk about your viscosity. Spelling cheppandi ra okasari. I get confused in the viscosity spelling, okay? Viscosity. SITY leda CITY. I think it's correct. Viscosity. Right. Viscosity and enti, sir. Viscosity in the sense the friction force between the layers of the liquid. Ide kada? You can simply say, sir, viscosity is nothing but the friction between the layers of the liquid. Ide kada? Yes. The friction between the layers of liquid. If you're saying that you have liquid, this liquid have some layers. And when you're trying to move that liquid, the layers rub against each other. Yes, SITY kada? Yes, SITY. Correct. Spelling is correct. Right. This friction, whatever is there, this friction could be related to your viscosity. It's not viscosity. Hey, good Petru. Viscosity is not friction. Friction is not viscosity. They are linked. Okay, they are linked. And this concept, mottam viscosity concept, it was completely explored by your scientist. What is the name of the scientist? Cheppu. This concept of viscosity was told to us by a scientist. His name was... Hey, non-Newtonian fluids gurinchi telusa kada. You see on the reels, non-Newtonian fluids, Newtonian fluids, something like that. This is the guy. He has a contribution in mathematics, entire calculus. He told about your mechanics, law of gravitation, laws of motion. He talked about your heat, Newton's laws of cooling. He talked about your light, corpuscular theory. He talked about your liquids. And he was 25 only, 25 years only. Just only. Anyways, try to understand. Okay? Try to understand. I'll tell you the experiment. I will tell you the experiment that he did. Chuskondi andariki. So Vadu, he took 2 plates. Try to understand. Okay, this is a first plate. This is a first plate. And exactly below this first plate, he kept another plate. Hey. How should I write? La, 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 la. It's something like this, kada? Yes. And I think I should join these two. There you go. I'm not interested about the remaining figure. I only want this. I don't want you. How to type it? Hey, try to understand, all of you. Okay, try to understand. So these are the 2 layers of plates, liquids. Okay, liquids. Sorry. So what he did is he actually placed some liquid between the 2 slides. Choose code. So this was your liquid, okay? This was the liquid. Sandwich, telsa. He took 2 plates and then he had filled the 2 plates with a liquid. Now choose code. Okay, now some terminologies are there. Now there are some terminologies. Try to understand. The first terminology is your y, height y. Okay, y. The second terminology is your area of this plane A. The area is A. Try to understand. Okay, try to understand. Now. Hey, andariki. What Newton did is he actually moved a single plate. Ante E plate ante this face, whatever area it is, okay? It's area kada? Yes. He started moving this plate with the speed v. Andariki chudandi. Okate plate. This plate was constant. Okay, something like this. And he is only pushing this upper plate. This is constant, okay? It's not moving. It is only moving. Something like this. But koncham samayam tarvata, what happened is some layers, chuskondi, the layers that were exactly stick to this plate. Okay? These layers, andariki. These layers these layers started moving with the plate itself. Yes, and the layers that were exactly close to the lower plate, and these layers of liquid, the speed v equals to 0, and for these layers the speed v equals to v, same upper speed lower speed. Choose ante if you see over layers ante you come slowly downwards ra, speed v nunchi it is getting 0, ante speed is decreasing. For each and every layer the speed is decreasing, and finally last layer ki speed ante 0 ra, endukante the speed of the plate is also 0. ide kada? Yes. Ippudu try to understand, okay, what is the change in speed ra? Sir, upper speed minus lower speed, delta v is equals to v minus 0 equals to v. ide kada? Yes. Me delta v value ochindi ra. What about the height ra? Height, it is changing over height kada? Yes, height is y. So he talked about a terminology, velocity gradient. Understand? He talked something about your velocity gradient. చూసుకోండి అందరికి, velocity gradient అంటే it is dv upon dy. ఇదిగో finished. dv అంటే change in speed రా, అంటే v కదా? Yes. So dv by dy is v upon this entire distance y. ఈ క్వశ్చన్ లో అంటే ఈ స్పెసిఫిక్ కేస్ లో your dv by dy is v upon y. Correct. Delta v upon delta y. And he found out the friction force between the layers. ide kada? You are rubbing it, so there is some friction force between these layers ra. This friction force is viscous force. What ra? Viscous force. So he simply said, sir, this viscous, spelling ra, this viscous force has some properties. Ante this viscous force is directly proportional to velocity gradient, ante dv by dy. And at the same time this viscous force Fv, it is directly proportional to area of the plates ra. Chuskondi area kada? So combine andariki. Can I simply say, sir, your viscous force directly proportional to area multiplied by dv upon dy. Idigo, you have proportionality constant, remove it, replace it with a constant number ra. So in case lo your viscous force is equal to some constant. The constant we will call at eta. Eta ante coefficient of viscosity. Ante kada? Yes. So eta into a into dv upon dy. Idigo. Now this friction force kada? Friction force ante opposite in direction. Kabatti if you want you can write the negative sign also. But this negative sign only represents the direction. Ante the force is acting opposite to the speed. Ide kada? Yes. So your viscous force is minus na dv upon dy. Try to understand. There have been questions ra, PYQs lo it has been asked me viscous force Fv is equals to minus eta a dv divided by dy. Idigo. You are understanding? Something like this. Yes. E eta ante this eta is the coefficient of viscosity. One more thing, students, చూసుకోండి. When you are introduced to new constant రా, ఎప్పుడైనా మీకు new constant వస్తే you should be writing about their units, their dimensions. This should be your prime goal. Okay, ఇదే కదా? What is the formula for coefficient of viscosity? Eta is equals to f into dy divided by a into dv. ఇదే కదా? Force unit చెప్పండి ఒక్కసారి. Newton. If you want to write in kg meter square, you can write it, okay? You can write it. Force ante kg meter square multiplied by dy. dy ante length in change in length. It has a unit meter ra. Idigo area is meter square. dv ante speed meter per second kada? Yes, meter per second. So meter square gone, meter kuda gone, ante it is simply equals to kg second ra. This is unit. Unit ante you should be also calculating the dimension. Dimension ante enti ra? The dimension is mt. Idigo finished. Or if I am doing some mistake, tell me. Okay, sorry. If that's completed, let us talk something about your Stokes law. Okay, right. Stokes law. Student. Stokes law ante enti ra? you understand, okay? Stokes law is a very widely spread law. Yes, Poisson is the unit. Correct. You can say the unit of coefficient of viscosity, but I'm only interested about the actual unit. Newton and kg meter square. Similarly. Hey, I'm sorry. We are doing some mistake, ra. The mistake is there. Chuskondi. There is some mistake. Force ante MA ante kg meter per second square into dy is malli okasari meter ra divided by area is meter square multiplied by dv ante meter per second. Ide kada? You can do it now. I have written meter square. Okay, meter gone. Meter gone. Per second square ante kg per second square into chuskondi. This second goes up and this meter remains up. So this is kg per meter second. So on and so forth. Okay, you do whatever you want to do. Next, chuskondi Stokes law. Hey, my major goal was to tell you about Stokes law. Chuskondi. It is very widely spread law, Stokes law. And the Stokes law is different for a cube. It is different for a prism. It is different for a sphere. Okay? Different for a sphere. Dan tarvata whatever you do it, okay? If I'm doing some mistake, correct it. You can do it, kana? Yes, you can do it. Sorry. Now it is different for a rod. It is different for a plate. You are understanding? It's different for a triangular laminar. So every case has different applications. We don't have to jump in all these cases. Whenever we talk about Stokes law, we only talk about spheres, okay? Spheres. Stokes law is only not valid. It is only applicable for spheres. Our domain is not that much of extended. You cannot discuss for cubes. You cannot discuss for cuboids. You cannot discuss for prisms. You cannot discuss for cones. You cannot discuss for hemispheres. You cannot discuss for planar objects. You're understanding? Okay. Yes. Okay, sorry. So Stokes law, we'll only be talking our discussion. Hey, it is limited to spheres only. Here we go. So we are only talking about the Stokes law that is limited to spheres. Enduku spheres, sir? Sphere have the perfect curved surface kada. A curved surface to you can simply do the calculations that are not required for you and me. Hey, NEET students, so you only have to remember about the results. Good point. Yes. What is the result, Ra? Can you tell me the direct Stokes law result? Cheppandi. How many of you know the Stokes law? Formula kavali ra naku. How many of you know it? And how many of you don't know it? How many of you know it? How many of you don't know it? Not terminal velocity. Terminal velocity, we are not talking about it now. Stokes law, we talk about the force. What force, sir? Viscous force. What viscous force, sir? What viscous force? Yes, correct. Rabbit, correct. But what is that? You have written the expression, that's correct, 100% correct. But what is this expression for? What is this expression for? Nobody knows. Just so, liquid unte, let us say this is your liquid, okay? Correct. Right. Radius is R. Andariki chudandi. Your radius is R. And if at all you are holding this with a string, andariki, okay? This is you. This is you, okay? You are pushing this with a string, andariki. Cheppandi. Ide kada? Yes. Now, your main responsibility ante to move this sphere with a constant speed, ra. You are understanding? Yes. It is chala kashtam. Endukante there are some forces inside it. It's not a simple thing, ra. It's a maze. You are understanding? Konjam dayam. They are there in it. Now, what you do is, your responsibility is to move it with a constant speed v. But chudandi. Ide kada? Yes. So if at all you are moving ante emaitadi sir, the layers of the liquid. So these are the liquid layers kada. Yes, so this is the liquid ra. This is also liquid kada. Entire liquid only ra. So what will happen, these layers, they will have to pass through like this, and here also the layers will rub against the surface kada. When it is going, they are rubbing the surface. Chuskondi ante these layers will exert the opposite force. Ee force ante viscous force. Very good, very good. Ee case lo your viscous force Fv, it is directly proportional to the radius of the sphere. Similarly, your viscous force, it is directly proportional to the speed. Ide kada, combine ante your viscous force is directly proportional to the radius of the sphere and speed. ఈ proportionality constant ని మార్చేసుకోండిరా. You can simply say, sir, your viscous force is nothing but some constant. What is that constant, sir? 6 pi eta. 6 pi eta. 6 pi eta r v. ఇదిగో, and direction will be opposite. ఎందుకంటే your v is to the right and your force is to the left కదా. So this is the viscous force. Other, you have one more equation. ఇక్కడ నుంచి కూడా you can find the value of coefficient of viscosity dimensions. Your viscosity is f divided by rv. ఇదిగో, dimensions గురించి మాట్లాడుతాం, చూసుకోండి. Do it by yourself. ఇదే కదా. Yes. Sir, now let us talk something about your terminal velocity. చూడండి అందరికి, let us talk something about your terminal velocity. ఇదిగో, your terminal velocity is not restricted up to liquids only ra. Okay, the rain that is falling kada, even the raindrops, they attain a terminal velocity. Endukante they are traveling through the air. Air is also fluid unte your entire rules are valid on air also. Ante your raindrops that are falling, they follow this terminal velocity concept. Chuskondi, the concept is very simple ra. If this is your tube, okay, if this is your tube, in tube lo you have some liquid, okay, something like this. I should say something like this. And this is your tube kada. Yes, in tube lo you have your liquid something like this. In liquid nunchi you are having a sphere andariki. So this is your sphere, radius r, and it is going to come down kada. Modatiga when you are releasing this sphere ra, chudandi, your speed is 0, force is there. What force? Gravity. This gravity force will try to increase the speed. If the speed is increasing, the viscous force is increasing. Viscous force acts opposite to the force. Ante you understand, it's a chain reaction happening ra. Chudandi, initial speed u is equals to 0. Kani you have initial acceleration a equals to g in the downward direction. Due to this acceleration, the speed has increased. Ide kada, speed has increased. Once again, if the speed is increased, the viscous force increases. If viscous force is increasing, ante it will oppose the acceleration, and the net acceleration decreases. If the net acceleration is decreasing, the change in speed also decreases. If the change in speed is decreasing, your change in viscous force also decreases. Can it's there? That change in viscous force again decreases the acceleration. You are understanding? Until and unless there is an equilibrium condition. Chusko. Equilibrium condition ante entira. Initially it is moving with some speed u. I don't care. Okay? What's happening, sir? In case lo there are some things that are happening ra. What are the things? Can you tell me? Andariki cheppandi. What are all the things that are happening in this case? Can any one of you tell me? All of you. What factors do I need to consider? Cheppandi. Okay, viscous force, viscosity. So you can imagine a condition ra. If this is your condition, it is going down kada. Yes. At this instance, the velocity remains constant. You try to understand, okay? You try to understand, all of you. In case lo, your velocity becomes equals to v. V ante your terminal velocity. I'm telling you, just remember this, okay? Just remember this. This is the final speed with which the ball will be descending. Ante, ippudu the speed will not increase. Okay? Radius r. You try to understand radius r, density is liquid, density of the solid. Sphere, okay? Density of sphere, density of liquid, radius r, terminal velocity v. అర్థమైంది కదా? Coefficient of viscosity is eta. ఇది తీసుకోండి. Now what you will do is you will try to write all the forces. అందరికి చెప్పండి. The first force is acting in the downward direction అంటే gravitational force. What next force రా? Viscous force. Viscous force కదా? Yes. Viscous force is acting in the upward direction. చూసుకోండి. And the viscous force is only acting on the surface itself. ఇదే కదా? Friction force రా అంటే it is acting only on the surface of the sphere. దాని తర్వాత there is one more force. One more force అంటే buoyancy force FB ఇదిగో. So sir, there are two forces in the upward direction. ఒకటే force in the downward direction. Equate them అంటే your gravitational force Fg should be equals to your viscous force plus your buoyancy force. ఇదే కదా? ఇప్పుడు మీకు ఇండిపెండెంట్ గా ఫార్ములా గుర్తుండాలి ఈ క్వశ్చన్ అటెంప్ట్ చేయడానికి. ఎందుకంటే if you don't know the equation you cannot proceed. అదే you understand these are small derivations, చిన్న derivations ఉంటే the proofs also you must understand them. Okay, the proofs also how they are coming. Okay, సరే ఇప్పుడు ఫార్ములాస్ చెప్పండి రా. గ్రావిటేషనల్ ఫోర్స్ అంటే మాస్ ఆఫ్ ద స్ఫియర్ ఇంటూ జీ ఇదే కదా. విస్కస్ ఫోర్స్ అంటే ఏంటిరా? విస్కస్ ఫోర్స్ ఇస్ నథింగ్ బట్ మాస్ ఆఫ్ ద లిక్విడ్ డిస్ప్లేస్డ్ multiplied by g plus your it should be buoyant force. Your buoyant force is like this plus your viscous force is 6 pi eta r v. ఇదే కదా? If it is the extreme position అంటే your v becomes terminal velocity vt. అందరికి చెప్పండి. Your v becomes terminal velocity. So mass of the solid is how much, sir? Volume of the solid 4/3 pi r cube multiplied by density of the sphere multiplied by g should be equals to 6 pi eta r v plus mass of liquid చెప్పండి రా ఒకసారి. It is simply equals to density of liquid multiplied by volume of solid. ఎందుకు సార్? Archimedes principle. Volume of solid equals to volume of liquid displaced. Volume of solid ఎంత సార్? 4/3 pi r cube multiplied by g. ఇదిగో ఇదే కదా? pi gone. What else gone రా? r 1r gone. So you are left with 2 also gone కదా? 2 this 3 this 2 రా. ఇదిగో you are left with 2/3 r square only multiplied by density of sphere into g should be equals to 6 అంటే it's only 3. అందరికి చెప్పండి 3 కదా? Yes. You are left with eta and then you are left with your terminal velocity vt plus మళ్ళీ ఒకసారి it is 2/3 చెప్పండి density of liquid multiplied by r square multiplied by g. ఇదిగో ఎక్కడ నుంచి what you can say is మీకు vt కావాలి కదా, terminal velocity కావాలంటే you simplify everything. Let us increase it. So the formula is 2/3 into r square into density of the sphere multiplied by g should be equals to 3 eta terminal velocity plus 2/3 into r square into density of the liquid into g. ఇదిగో ఈ మొత్తం పంపేయండిరా. So you can simply left with 2/3 కామన్ తీసుకోండి. r square g కూడా కామన్ రా. r square g కూడా కామన్. So density of sphere minus density of liquid is equals to 3 into eta into terminal velocity vt. ఈ మొత్తంని కూడా you send it that side. So you are simply left with your terminal velocity is equals to 2/3 multiplied by r square g multiplied by density of sphere minus density of liquid whole divided by 3 eta kada. 3 eta simplify చేసుకోండి. You are having your terminal velocity as 2/9 into r square g into rho s minus rho l divided by eta. Hey, can you remember this formula? Can you remember it? If you're remembering, very good. Very good. If you're not able to remember the proof. Dekada? Question paper lo, if they are asking it, you must be able to derive that very quickly. So it is 2 by 9 into r square rho s minus rho l divided by eta. Idigo r is, you remember it like this ra. Chusko your terminal velocity vt is equals to 2 by 9 number good pettukondi. Then you write about rho s minus rho l divided by eta ra. Idigo multiplied by r square. You can remember it like this also. So all up to you. You can remember however you want. Okay? So your viscosity has been completed. Sorry, next. Ippudu you are done with your fluid dynamics. You are also done with your you are done with your water. You are done with your, you are left with half an hour. It will easily get completed. Okay, sorry. You are also left with your, what is left? Surface tension. Surface tension is only left. Tell me if I am forgetting something, okay? There are some factors I cannot teach. If you have a cylinder full of water, what is the force exerted by first half on the other half? Not required for you. Yes. So let us talk simply about your surface tension. Let us talk something about your surface tension. And this is the last topic of our discussion. Surface tension ante that gets last topic of our discussion. Yes. So in your surface tension, what is it? How it changes? All these things we'll be studying one by one. Let us talk about your surface tension. The best example, the best example to study surface tension is your bubbles. Soap bubbles. Okay, soap bubbles. So you do one thing. You have a ring. Okay, take a ring and you dip that ring into soap solution. You dip that ring into a soap or your detergent powder solution. What happens is a film is getting deposited on the ring. Soap film kada. Jagrataga chudandi. The soap film gets developed in the between the ring. Ide kada? Right. Now, what you will do is take a string. Okay, string. String it should be closed string. And tie it up. So this is your string, Randariki. This is your string, okay? What will you do now is you simply take this string and put it over here. Your ring, soap fill. This soap fill you are releasing a string. Yes. Okay. We will discuss PYQs also. There is no problem, okay? We will discuss PYQs also, but I am trying to finish your syllabus as soon as possible. In the one day, we are not having enough time. So if you are taking each and every PYQs, the class will easily extend till 8, 9, 10, 11 hours also. Okay? So anyways, what's happening? You have a soap fill. Okay? A soap fill, you are releasing a string and closed string. And once you have released, you take a pin, and you hit it and the film between this string breaks. The film between the string breaks, and kuncham samayam tarvata you will be able to see that this strange shape has now become a perfect circle, something like this. Try to understand. That there are some experiments on Instagram also, like YouTube also, you watch them. So what is happening here ante, the surface, the film, the soap film that is there, it is pulling this string in each and every direction. Sir, it is pulling and it has some force. Some force. Choose code. It is pulling yes, and it has some force. Whatever that force is arrived because of the surface tension. Tension and force only. Yes, choose code. Surface tension ante, it is the force that has been arised. Okay? Arised. So you can simply say, sir, if at all you have a film ante, this. Hey, try to understand all of you. This is your film. soap film తీసుకోండి, soap film, right? The standard, most standard case, soap film. సరే కదా, రైట్. నౌ యూ ఇమాజిన్ అ లైన్ రా, యూ ఇమాజిన్ అ లైన్. ఏం లైన్ సార్? ఇమాజినరీ లైన్ తీసుకోండి. ఆన్ దిస్ ఫిల్ యూ టేక్ ఎన్ ఇమాజినరీ లైన్ సార్. ఇదిగో దిస్ ఈజ్ యువర్ లైన్ ఎల్ కదా. నౌ వాట్ యూ విల్ అండర్స్టాండ్ ఈస్ దేర్ ఈజ్ అ ఫోర్స్. ఫోర్స్ అంటే ద ఫోర్స్ ఆన్ అన్ ఇమాజినరీ లైన్ ఆన్ ద ఫిల్మ్ ఓన్లీ. ఈ ఫోర్స్ అంటే ద ఫోర్స్ విల్ ఆల్వేస్ బి పర్పెండిక్యులర్ టు ద లైన్. ఇదిగో, so this is your force ra, ide kada. Let us say the force is F, length is L ra. So your surface tension is defined by two letters. Some books use S, some books use T. Okay, you can take whatever you want to take. Some books use S, leda some books use T. Surface tension is this. It is simply equals to the force divided by the length. What force, sir? The force with which the film pulls the imaginary line. What is length, sir? Length ante the length of that imaginary line. Ante kada? Yes. Try to understand, all of you. Surface tension is one of the most phenomenal property ra. It is one of the most astonishing, surprising, beautiful phenomena in the nature. Surface tension. Idigo. Why, sir? Because if at all you have a liquid droplet, right? This is your liquid droplet, water droplet. Water droplet, it will never exist in this shape. Okate independent water droplet unte, it will never exist in this shape. If you have a water droplet, it will always be a sphere. You are understanding? Enduku, sir? Why, sir? Because of the surface tension. Idigo. Your water will never exist in this shape until and unless you are applying some external force on it. Understanding? But if you see a water droplet, it will be spherical. Why? Now I'll tell you some things, okay? Jagrataga vinandi andariki. So if it is your water droplet, okay? If this is your water droplet and the water molecules will be there kada. Yes. All of these are the water molecules. Andariki chudandi. They are water molecules, complete water molecules. What about the surface, ra? The surface is there kada. Yes. So the surface forms a protective shielding, ra. Chuskondi. The surface forms a protective shielding for these water droplets. The surface forms a protective shielding for these water droplets. ఇప్పుడు this surface చూసుకోండి, this surface has some water, some energy. Oh my goodness. ఇప్పుడు ఎనర్జీ ఉంటే your basic rule of every single thing in this universe tells a single thing. What? మీ ఎనర్జీ ఎక్కడైనా ఎప్పుడైనా it should be minimum. ఇదే కదా, every system in this universe, every system tries to keep its energy at a very minimum level. Andariki chudandi, your surface energy should be minimum kada. Yes, your surface energy leda whatever energy is there, it should be minimum. By default every system tries to be at the minimum energy state. Ippudu chudandi, you can simply say the formula for your surface energy. Andariki chuskondi, your surface energy is equals to, do you know the formula, ra? Surface tension multiplied by area. Idigo, surface tension T multiplied by area is your surface energy. Ante మీ surface energy minimum undalante your area should also be minimum. Area ante enti ra? Surface area of the sphere. Ade kada. What is the surface area of sphere, sir? 4 pi r square. That means your radius should be minimum, ra. That means the most favorable area for small surface is only sphere. Kabatti it does not exist in any random shapes, ra. Chuskondi. If you see the area here, it is more. Kani here it's very less. That is the only reason why water droplets లేదా ఏదైనా droplet ఉంటే they will exist in a spherical shape. అంతే కదా? Yes. So now if you want to take some questions, I'll take some questions. Okay, తీసుకోండి. Your surface energy is equals to గుర్తుపెట్టుకోండి, ఈ ఫార్ములా గుర్తుపెట్టుకోండిరా. your surface energy is equals to your surface tension multiplied by your area. ఇదే కదా? Yes. Let us take some questions, all of you. Okay? A water droplet, it's a PYQ, okay? It's a PYQ. I don't know, it's not a NEET PYQ, it's a JEE PYQ. JEE PYQ. Okay? Try to understand. A water droplet of radius r, okay, splits, I should say splits into 4 more droplets. Leda, it splits into 4. Full stop. If the surface tension is, let us call S ra, ee case lo, find the heat generated. Find the heat generated in this procedure. Calculate. I don't know if it's a PYQ. I'll check it. Okay, just a minute. Let me give a minute. Let us see if it's a PYQ or not. No. You have this question in 22. And it's a very simple question, right? This is actually a conceptually inclined question. Just go. Your PYQ states something like this. Let us take 2 questions only. Okay? The amount of energy required to form a soap bubble. Okay? The amount of energy required to form a soap bubble. Of radius 2 centimeter. There is a question from surface tension, but I'm skipping it for now. If you want, I'll take it. Okay, if you want, I'll take it. But hey, waste time only. We are going to take PYQs, kada? Yes. Hey, take one more information. Surface tension, surface tension is equals to 0.03 Newton per meter. The first option is 30.16 10 to the power minus 4 joules. The second option is 5.06 10 to the power minus 4 joules. The third option is 3.01 minus 4. Lastly, your option is you are understanding? Not understand. So let us take first this question ra. Idigo your water droplet radius r kida, yes, radius r is there ante volume cheppandi ra okasari 4/3 pi r cube ide kada 4/3 pi r cube is the volume. What is happening ra? Splits into 4 droplets ante it is breaking into 1 2 3 4 droplets. Kani while it is splitting ray andariki, while it is splitting the volume remains the same. Ide kada volume same undali ante the sum of all 4 volumes must be equal to the volume of this. Ide kada, should I say water droplet kada? It's yes, it's a water droplet, not a soap solution, right? I'm sorry. Good, very good, very good. Now volume should be same kada, so that means this entire volume should be broken into 4 pieces ra. 4 pieces ante divided by 4 sir, 1/3 pi r cube. ikkada kuda 1/3 pi r cube, 1/3 pi r cube. What I am writing about the values, okay, values and ikkada kuda 1/3 pi r cube. Kani let us say the radii independent radii ra andariki. Let us say the radii is r dash. Can you tell me the formula for volume of sphere once again ra? Sir, it is 4/3 pi into r dash cube. This is the volume kada, and this volume should be this much ra. Ante 1/3 pi r cube equals to 4/3 pi r dash cube, pi gone, 3 gone, r cube equals to 4 r dash cube. Send it that side. Sir, r cube divided by 4 is equals to r dash cube ra. Idigo. You got the values kada? Yes. Correct. Now let us take the cube roots of all of them, students. Cheppandi. So cube roots teeskondira okasari. So can I simply say, sir, your r dash value is equals to r upon 4 to the power 1/3 ante cube root of 4. Tell me the initial surface energy ra. Your surface energy is S into A kada. Surface tension into area. Surface tension S. Area is 4 pi r square. Idigo. This is your area. Ante 4 pi s r square. This is your initial surface energy EI. What about the final energy, sir? Compare, calculate cheskondi. Your r dash is this kada. Cheppandi. So what will be the value of surface energy, sir? E2 is equals to for one sphere. Okate sphere kosam. Cheppandi. It is simply equals to surface tension S multiplied by r dash square ra. R dash radius kada. R dash square ante r square divided by 4 to the power 2/3. Idigo. This is for one sphere. 4 such spheres are there. 4 spheres are there. Yes. 4 spheres are there. Ante your total energy E2 becomes 4 multiplied by S into r square divided by 4 to the power 2/3. There you go. So you do one thing. Take out. Hey. Am I doing correct? No, I'm not doing correct. I'm doing some mistake. What is the mistake, sir? Your surface energy is surface tension into area. Area is 4 pi r square. So it should be 4 pi r square, something like this. Ante S multiplied by 4 pi r square divided by 4 to the power 2/3. This is for a single sphere. And 4 such sphere are there. So multiply cheskondira. So your final total energy is 4 into E mottam. Ante 16 into S into pi r square divided by 4 to the power 2/3. You can do it something like this also. So it's 4 upon 4 to the power 2/3 multiplied by cheppandi 4 S pi r square. This is your E2 value. This is your E1 value. Subtract cheskondira. Ide kada. So change in energy delta E is equals to E2 minus E1 andari. E2 minus E1 ante how much, sir? E2 value cheppandi okasari. Your E2 value is 4 by 4 to the power 2/3 multiplied by 4 S pi r square minus E1 value is 4 S pi r square. Common teeskondira. So you can simply say, sir, 4 S pi r square has been taken common. Ide kada? Yes. What next? You are left with 4 by 4 to the power 2 by 3 minus 1. Here you go. This value is greater than 1. Greater than 1 until there is no heat generated. You will have to get some energy. You will have to give some energy. Energy has increased. Try to understand. All right. You do it like this. Let it be. Now, if you want to do it, you can do it. The surface energy is equals to surface area, surface tension into area. Okay. Surface tension value is sir 0.03. Area value cheppandi sir okkasari. Amount of required to form a bubble of radius 2 centimeter. Okay. Centimeter ante 4 pi r square ante 2 centimeter whole square. Can I directly write 4 into 10 to the power minus 4 andariki cheppandi. So let us do one thing, 1, 2 and minus 4 and 10 to the power minus 6 is there. You are left with 3 into 4 into 4 pi. Idigo. So 16 into 4 pi and 64 into pi value approximately 3.1 ra into 10 to the power minus 6. Ide kada? Do the calculations. Simple. Yes, you are saying it's C, so C is the answer. Okay, do it. I don't have much time. Now, let us talk something about excess pressure. Excess pressure, okay? Kani, before that, I want to tell you something. Andarki chuskondi. If this is your soap bubble, try to visualize, okay? Try to visualize. Soap bubble, and it's a film. It's a soap solution film. Yes, it's a soap film. There are two sides, andarki chudandi. The first side is your left side. The second side is your right side. Ide kada? Now what you are doing is, you are blowing some air, you are throwing some air into it. Ante high pressure kada, the pressure is high here. Emaitadi sir? After some time, the same film that was straight, it will take some this shape. This type of shape will be taken. You are understanding? If you blow air into it, it will become a curve. Yes. It will become a curve. It becomes into a curve, transforms into a curve. Hey, understanding? Good. Not understanding? Idigo. So this is your curve. Okay, something like this. You blow air into it, it will become a curve. Can you tell me the pressures? Pressures. So if you see, it's a concave side, it's the convex side. Idigo. This side is your convex side. This side ante ide me concave side kada. Yes, this side is your concave side. Ante let us say pressure is P1 here, pressure is P2 here. Can you tell me where is more pressure, sir? Hey, you just now thrown the air here air. To maintain this shape andariki, to maintain this shape, you will have to blow. You will have to keep blowing kada. Yes, you will have to keep applying the pressure. Ante your pressure should be more. This pressure should be less. And it is understood that P1 greater than P2. Ante epadaina mee daggara oka curve ante spherical shape, curve. What should I say? Curve teeskondi. If this is your curve, andariki try to understand. Okay, try to understand. If this is your curve, you have the concave side and convex side, andariki. So pressure at concave side is more than pressure at Arthamindi kada? Yes. So this is the shape that you have. Now try to understand, everybody. Let me just revise about the surface tension formula, sir. T is equals to, can I simply say write is force into length of the wire, length of the imaginary line. Ide kada? Yes. Surface tension is force divided by length. Ante ekkada nunchi can simply say, sir, your force is equals to me surface tension into length ra. Idigo. Ide kada? Your force is equals to your surface tension into length. Hey, based on the same principle, you have some questions also, right? And lifting things from the film. Try to understand, okay? Try to understand, everybody. So if at all you have a circular film, okay? This is your film, ra. Let us say you have a cylinder, okay? Andariki, Jagrataga Vinandi, all of you, try to understand. If this is your cylinder, I have placed on this film, Andariki. Can you tell it? Can you see it? Can you see it, all of you? Yes. Now what you are doing is, you want to lift this cylinder up. Mass of the cylinder is m, very small mass, okay, very small. Straw, you take it, you take the cut, you cut the straw and you put it on the soap solution. Best example ante ide, you take the straw, cut it and put it on the soap solution. Ippudu the force that you will require is nothing but F equals to simply mg plus 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 plus, చూసుకోండి, plus 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 surface tension multiplied by the length. ide kada? Yes, you are taking surface tension multiplied by the total length L ra. What is the total length, sir? What is the total length? Ippudu you must be very good with finding the lengths. Andariki చూసుకోండి, total length ante ide. Try to understand. Whatever length is in contact with the layer, చూసుకోండి, if height is h, ఈ height kuda h kada, total length is 2h. 2h, yes, yes, ante your surface tension multiplied by 2h. idigo, this is the extra force that you require ra. I am assuming that it's a single film, okay, single film. I did not say it's a soap film. Single film unde this. If it's a soap film, it has two surfaces. We will see everything. Try to understand. Okay, sorry, let us take one more example ra. This is your ring kada? Yes, ide. This is your ring andariki. Try to understand. Ring leda disc ra, don't care. I am only interested about the length. Length ante periphery same kada. Ee mottam kosam the periphery is same ra. Periphery గుర్తుపెట్టుకోండి, periphery. What is the periphery value, sir? Radius r unte your circumference is 2 pi r. idigo, this is the total length. Ippudu if you are putting this ring on a soap solution, మరి ఏమైతుంది sir? Mass m unte you pull it ra, you pull it with some force F. So this force F must be equals to the gravitational force plus surface tension force. What is the value of surface tension, sir? F into L, T into L kada? Yes, surface tension T multiplied by length is 2 pi r. idigo, for understanding, try to understand. Film ante you take the ring, okay, oka ring తీసుకో, you dip it into the soap solution, you form a film, you blow it, bubbles form kada, that film, soap film is there. Not exactly soap films unte two surfaces ఉంటాయి, రెండు surfaces ఉంటుంది, and that scenario becomes very, different ra. Try to understand. I am assuming it's a single film, okay, single soap film. ఇప్పుడు చూసుకోండి, we are talking some things about your water droplet అందరికి, water droplet versus your soap bubble. Okay, soap bubble. ఇప్పటి కోసం just గుర్తుపెట్టుకోండి, okay, you don't have to go into the details here, why only one surface, why two surfaces. I am telling, that's why you remember, okay, there are two complicated proofs. So this is your water droplet randariki. So complete water is there and you have a surface kada? Yes, your surface is equals to 4 pi r square. idigo, and you have a single surface. You remember these things, okay? You have a single surface for a water droplet. Kani when it comes to your soap bubble, చూసుకోండి అందరికి, your soap bubble has two surfaces, okay? Your soap bubble, it has two surfaces. Surfaces ante external outer surface and the inner surface ante your gas ఉంటుంది కదా, air ra. ఈ soap bubble lo you have air, blow it, bubble forms, ante kada. So this is your air andariki. So whatever surface is in contact with the air is the inner surface, and whatever surface is contact with the external air, ide మీ external surface, ide kada? Yes. So this is the thickness andariki, చూడండి, this is the thickness of the soap bubble. It's a 3D diagram. Try to visualize it, okay? Try to visualize it. Student, if your thickness is T, okay, if your thickness is T, andariki, should I take it or not? Let it be, right? I'm not interested in thickness. Try to understand. Okay? There are two surfaces. Ide kada? Right. Two surfaces. Ippudu I want you to focus on this part ra. Hey, on this part. So if you have a curve, మీ concave side has more pressure than your convex side. Good pettukondi. Just remember this, okay? Just remember this, all of you. Try to understand, okay? Try to understand. So when you talk about your single water droplet, okay? When you talk about your single water droplet, andariki. So this is your single water droplet. Let's say something like this. Okay? This is your single water droplet, ra. Try to visualize ide, and there is full of liquid kada, yes, and this droplet is full of liquids. What will happen if I cut it? Can anyone of you tell me, ra? What will happen if I cut it? Andariki cheppandi. What will happen if I cut it? Cut and separate it. Ante something like this. Try to visualize. I'm cutting it and separating it. Ide kada? Yes. Yes. You understanding the dimensions, ra? Ante this will look something like this. Try to visualize. Okay? Try to visualize. Visualize cheskondi andariki. So this is your first hemisphere, and ide mi second hemisphere kada? Yes. You cut it. You break it. Two hemispheres, ra. Ante kada? Yes. ఇప్పుడు మీ దగ్గర లిక్విడ్ ఉంటే వాట్ ఎవర్ దిస్ లిక్విడ్ ఇస్ దేర్, లెట్ us color it blue liquid. Okay, it is your blue liquid and it is your pink liquid ra. Actually they are same కానీ now they are cut అంటే right liquid left liquid. What is happening andariki? Try to understand. When these two are very close అంటే something like this. Try to visualize. Okay, when they are just about to be a single sphere, ide kada? Yes. When they are just about to be a single sphere, what is happening, sir? Your blue liquid is exerting some force kada? Yes, something like this. Chuskondi all of you. Ide kada? Yes. Pressure P multiplied by area. Force ante pressure into area kada? Yes. So let us say the internal pressure is Pi and let us say the external pressure is Po. Outer pressure. Pi ante internal pressure, Po ante outer pressure. Ide kada? Yes. Now try to understand, everybody, all of you. You will simply say, sir, your total force ante enti ra? The question is, chuskondi, the question is why? The question is, why is this sphere not cutting by itself ra? Ide kada? If the liquid is applying force, why the drop is not breaking? If this liquid is pushing this right side in the opposite direction, why is the drop not breaking ra? Because of surface tension. Chuskondi, ee surfaces ni chudandi andariki. Can I say that these two surfaces ra, this one for the left one and this one for the right one ra, they are attracting one another. Try to visualize. Hey, try to visualize. And this is applying kani. When you see the surfaces ra, this surface is pulling it, and this is your surface tension force andariki. Ide kada? Did I say it? Can I say it? You try to understand andariki. The pressure difference is there. For sure the pressure difference is there. Ide kada? Yes. So this difference in the pressure andariki jagrataga vinandi. Okay, jagrataga. Can I simply say, if this is pressure outside, this is your pressure inside ra, this pressure difference should break the liquid droplet. Ante you can simply say, sir, your delta P multiplied by force kavali kada? Force. Sir, see, your pressure difference into area. Area is how much, sir? Area of this phase ra. Idigo. Ade kada? Yes. So area of this phase is pi r square. Should be equals to the force between the surface tension. Ante the surfaces ra, they are attracting one another. How much, sir? How much? Your surface tension T multiplied by total length ra. Total length. Chuskondi. Ide this total length. What is it, sir? What is it, sir? 2 pi r. 2 pi r. Ade. Vedantu, pi gone, r square r gone. You can simply say your change in pressure is equals to okate r untundi kada, send it that side. So you can simply say that is equals to 2t upon r. If you are understanding this, good. If you are not understanding it, good pettukondi. Ante enti ra? Ante if you have a soap bubble, try to visualize. Okay, visualize cheskondi andariki. If you have a soap bubble, okay? Not soap bubble, water droplet. Okay, water droplet andariki. మీ దగ్గర ఒక వాటర్ డ్రాప్లెట్ ఉంటే what you will say is you have two different pressures, internal pressure and external pressure కదా? Yes. చెప్పండి అందరికి. You have two different pressures ra. Your internal pressure and your external pressure. Oi. I mean, move to color something. P internal, P external. Should I change the color? I think I should change the color. Which color should I take? Oh, this is the color I'm taking. It is my P internal. Choose one. Concave side and T internal pressure. Concave side. That means P internal will be more than P external. What is the difference? Delta P and P internal minus P external. That should be equals to 2T upon R. Ide kada? For a soap bubble, soap bubble kosam cheppandi okasari. So you can simply say for a soap bubble, ante you have two surfaces for a soap bubble. Ide kada? This is your first surface. Ide nee second surface ra. Ippudu rendu surfaces unte you have 2 times the surface tension value. Ade same working ra, same principle. Okay. The only change is in case you have T, for soap bubble you have 2T. Two surfaces untundi kada? Finished. Write the same formula, sir. Same formula ante your delta P multiplied by pi r square. Idigo. Your delta P into pi r square should be equals to surface tension. Ippudu two surfaces unte 2T multiplied by the length. Length ante 2 pi r. Finished. Ide kada? Simplify. It comes out as 4T upon R. Leda 4S upon R. Correct kada? Yes. It becomes, simplify cheskondi. Your delta P is equals to 4T divided by R. Finished. This is your soap bubble. Ippudu, I'm saying something wrong. Was I saying something? I'm forgetting something. Angle of contact. Sorry kada? Yes. Let us talk something about your angle of contact. Angle of contact ante entira. If you have a drop, water droplet, okay? Water droplet. You take a water droplet and you put it on two different surfaces. For example, let us say this is my glass. Na glass. Let us take it some metal, okay? Metal. Metal. Okay, right. In glass lo, you have some water droplet. Andariki. What is the difference, What difference can you see? Cheppandi okasari. Yes, it will be done. It will be done in 10 minutes, okay? 10 minutes to complete, Don't worry. We will be done in your 10 minutes only. We are only left to discuss about this angle of contact. yes. చూసుకోండి. When you talk about angle of contact, angle of contact is simply measured from the surface and draw the tangent. To find the angle of contact, number one, draw tangent to the curve. Arey ekkada ra? At the junction ra. I should say junction. Okay, at the junction of surface. Idigo. That means this is my curve, this is the junction. Ippudu I have to draw the tangent kada. So this is the tangent. Andariki chudandi. Ide. This is tangent kada. Tell me here. Junction is here, sir. Kabatti the tangent looks something like this. Ide kada. Try to understand. Ippudu angle gurinchi cheppalante the angle should be this theta. Idigo. Here also the angle is theta. Kani ఈ కేసులో ద వాల్యూ ఆఫ్ థీటా ఈజ్ లెస్ దెన్ 90 డిగ్రీ రా, అండ్ ఈ కేసులో అప్టూస్ యాంగిల్ కదా ద థీటా వాల్యూ ఈజ్ గ్రేటర్ దెన్ 90 డిగ్రీ. ఈ థీటా అంటే దిస్ ఈజ్ యువర్ యాంగిల్ ఆఫ్ కాంటాక్ట్. ఓకే, ఎస్, కరెక్ట్. సో ఇఫ్ యువర్ యాంగిల్ ఆఫ్ థీటా, I'm telling you in a short and simple words, not adhesive, not cohesive, too much confusion. Try to understand. Okay, try to understand. If at all you say that you have a water drop, understanding an angle leda angle of contact is less than 90, acute angle unte, you will simply say that if the value of theta is less than 90 degree, that means the liquid, okay, the liquid wets the surface. Idigo ante kada. That means you move this surface ra, emaitadi ante there will be the wetness of this liquid on this surface. Kani if theta value is greater than 90 degree, the liquid does not wet the surface. For example, your mercury ra, you move it perfectly goes ante it's a very dry surface. After mercury has been gone, the surface remains dry only. Ide kada. Yes, you are understanding, not understanding ra, all of you. The angle ante your angle of contact decides the fate of your, the angle of contact decides the fate of your wetness or dryness. What's the time? 37 kada. One more thing that I want to discuss. Ante rise in the capillary tube. Let's skip the proof ra. Let us only look at the formulas. అదే దాని తర్వాత we will see some PYQs in the next slot అంటే your PYQ slots. చూసుకోండి. ఓకే, రైట్. సరే, you have a container. ఈ కంటైనర్ లో you have some water కదా. Yes. Now what you do is you drop a very small capillary అంటే తెలుసారా, small tube, something like this. Okay, it's a pen. Try to understand. It's a pen. You drop this into the liquid. ఏమైతుంది sir? As soon as you drop a liquid, I'm sorry, capillary చూసుకోండి. If at all your thickness is too much ra, color kuda, let us change it. చూసుకోండి. If at all this is your capillary tube andariki చూసుకోండి. This is the second one. They should be very close actually. Technically they are very close to one another, something like this. చూసుకోండి. Can you visualize? This is the capillary tube. ఏమైతుంది అంటే sir, the liquid that is there, the liquid, it usually goes to the height, something like this. Good పెట్టుకోండి. This is height ra. ఇదిగో this height కదా. Now how do you do it? You do it using the excess pressure. Okay, you consider 2 points. I'm telling you the hint. Possible చేసుకోండి, లేదంటే ఫార్ములా గుర్తు పెట్టుకోండి. ఓకే, డోంట్ స్ట్రెస్. సరే, your height is simply equals to, చెప్పండి, what is it ra? What is the formula for your height? Can anyone of you tell me? What is the formula for your rise in the liquid capillary? Okay, thank you so much. Thank you so much. If you are leaving, there are only 5-6 minutes left. Okay, if you can wait for 5-6 minutes, there you go. That's it. But anyways, it's all up to you. Okay, Chappandi. Nobody of you can tell me, Ra. You can simply say, sir, the change in the height h, the increase in the capillary tube is given as 2t cos theta divided by rho g r. There you go. R ante radius of capillary, ra. Radius of capillary. Jagrataga vinandi. I'll tell you the terminologies. T ante enti, sir? T is the surface tension. Ide kada? Yes. What about cos theta? Theta, sir. Theta is the angle of contact. It should be acute. You take it acute. Leda it's obtuse. Take it obtuse. Right? It's all up to you. Okay. Angle of contact. What next, sir? Next is your rho. Rho into density of liquid. 15 minutes extra kada? Anyways, we will be completing it. What about R? R is radius of capillary. Ante. ఇప్పుడు theta గురించి చూద్దాం. I'm talking some things about the theta. Okay, try to understand. If this is your capillary, ra, the water has been increased, but it is something like this. Try to visualize. Leda, it will be something like this. In rendu cases lo, you must be good at finding the angles. Okay, angle of the contact. Ante something like this. This is a surface. This is a surface. This is also liquid, kada? Yes. It depends completely on the surface, ra. Okay? If it's a glass and water, it will form different shapes. If it's glass and silver, water and silver, it makes a perfect 90-degree angle. Okay? In cases lo chudandi, you have two cases: the radius of curvature, either concave upwards or concave downwards. Edaina, whatever it is, don't care. Okay? Don't care. Draw the tangent. Idigo. This is your tangent at the contact. This is a tangent at the contact. Until this angle theta becomes angle of contact. Here also, this angle theta becomes angle of contact. Whatever is there, take it. Okay? R ante radius of capillary. R ante this radius. This is your radius of capillary R. This is your radius of capillary R. Andariki. I did not take the questions. If I take the questions, the session will be extended till 7 hours. 6-7 hours easily. What formula? Buoyancy formula. Your buoyancy formula, mass of liquid displaced multiplied by G. Finished. This is your buoyancy formula, okay? Buoyant force formula. Now, with that being said, we will be ending our session. Your mechanics has been completed. Okay? Fluid mechanics. Edaina doubts unte adugandi. If you don't have any doubts, then we may say goodbye, kada? Yes. Repu will be talking something about your thermal properties of matter. And we will talk something about your heat, calorimetry and all this. Mostly, okay? Mostly. We will talk about your thermal properties of matter. We don't have any lecture on 31st. Dan tarvata 1st of February, your entire modern physics. Okay? 1st February, we will be completing your entire modern physics. Andariki. Good petko. Okay. The notes will be uploaded. Okay? Andariki. After the session has been completed, give some time. The notes will be uploaded in the description section. You can take from that. Okay, thank you so much, everybody. Thank you so much. We may stop the session. Okay, good night, bye-bye, bye-bye, bye-bye. Good night. Sorry, if you don't have any doubts, then we can terminate this session. Yes, thank you so much. Thank you so much. Bye, bye, everybody. Bye, bye, bye. Yes, yes, I will take class today. It is because of the Bernoulli's principle, Ra. Okay, it is only because of the Not even that. Your Bernoulli's principle is responsible for multiple phenomena are there. Ra. Your aeroplane flying, your train speeds are there. You have a tube and a plastic tube, Ra. Okay, you take that tube and try to blow it by sticking close to your mouth, Ra. It will not blow. You separate it a little, blow it, it will blow. Ante kada? Yes. You want the proof? You want the proof? I can prove. Okay? You want the proof? I can prove. So I have two suspended papers kada. This is first paper, this is second paper. You are blowing the air, something like this. Something like this kada? Yes. So your air is completely going into the plane of the papers kada. Hey, something like this. Try to visualize. You are blowing something like this. Ante you consider two regions. Your first region is something here, Ram. It is your first region, okay? Exactly between the plates, between the papers. Your second region is somewhere here. Chusko. Air kada, air particles. Now you look about these molecules, their speed is high. You are blowing kada. You are blowing and the speed is more. Here, speed is less. Bernoulli's principle, ra. If speed is more, pressure is less. If speed is less, pressure is more. And speed more, less pressure. Speed less, and pressure is more. Here also, pressure is more. Here, pressure is less. So high pressure to low pressure. And try to understand. Sorry, bye everybody, bye. Good night.